Stream too. But yeah, cheers, bro.
Yep, cool. I just did webcam. It's through the live feed or whatever.
Oh, okay, then yeah, I'll go share it on the stream then. I'll make it
The
large.
virtual game. Okay, cool. All right.
Yep, it's good to
All
go.
right. All right, cool. All right, hello and welcome. This is the history of E equals MC squared and the philosophical implications, according to Shane, and and the significance of what that actually means, right? Because we're all told a story about E equals MC squared, and let's see, 1 second. Oops, just changed the wrong scene. Okay. All right, so on the history of E equals MC squared. So we've all been this guy before. E equals MC squared is physically made itself because it was utilized to create atomic bombs or some variation of something like that. Like we've all said something like that, right? We've all been that guy. So this is going to be the history of that relationship of E equals MC squared and charge mass relationships and that sort of stuff. So we're going to go over the basic history of it first. So starting with your boy Hassel-Norrell in 1904, he was doing experiments with a closed sphere and he was heating it up, and he found that the kinetic energy of that that pressure gave an apparent weight or mass to it, and he came up with a coefficient to calculate it, which he later changed. I have it reduced down, but anyway, this is just one of the early iterations of the charge mass relationship, and of course there was some other people before them. I think Poincare had one as too, but I just found out about that one today, so I don't have it fully incorporated. But Poincare had one, and then J.J. Thomson in 1897 found a charge mass relationship with the electron with his experimentation with the cathode tube. So I'm going to quickly go over the full experimentation that he did real quick because it kind of relates to some other stuff that I'm interested in. So I'm just going to kind of give the broad perspective overview on that, and then we'll tie back into the full E equals MC squared and Einstein and all that stuff. So here's J.J. Thomson and his electron charge mass ratio discovery. Okay, so what he was doing with the cathode tube is he had two copper wires hooked up to an anode and a cathode in the tube, and the anode had a slit in the center of it, so there was a focus of the current flow within the tube, right? And that current flow was exciting a filament in the tube, so it creates a green beam, right? And then a little closer towards like the middle of the tube or whatever, towards the endish, kind of, he had a magnet and a two plates to set up an electric current. So what he found is that the beam would kind of deflect proportional to the strength of the magnetic field and the electric current, and it would follow the left hand rule. So it would be attracted to the positive side of the magnet, right? So what mainstream science in physics and electricity or whatever says about how the electron works and all this, the relationship that they say is that the electron is generated from the anode and the cathode plates, and the charge disparity between them is causing a 1 second. 1 second, my live stream audio is not coming through. Testing. Can you hear me on Discord?
Yeah, I wasn't even checking your YouTube though. Hold on.
Oh, shoot. Thanks, Toby. 1 second, guys. Sorry about that. I'm not sure.
Yeah, you've been muted the whole time.
Yeah, no worries. I'll just get it off of Geos later and cancel it out. Okay, so let's see here. Oh, canceled my screen share. There we go. Still up, right? On Earth Awakening. We're still good on here, right?
Yep.
Okay, cool. I'll get it off of that later. No worries. Okay, so where were we at? The mainstream thing on the charge disparity creating the beam or whatever, right? So they say that basically like little charged particles are being ripped off of the photographic or off of the anode and cathode plates, and that those charged particles are going into a magnetic field, and they're basing this relationship off of the deflection of the intensity of the beam, right? Or the deflection of the beam based on the intensity of the magnetic field or the electric field. So the way that JJ describes it is that the behavior is it's acting as if the mass is being changed, right? But it's not an actual physical thing. And actually, the way that JJ originally interpreted it was that the electron was a little vortex, right? So we're going to get into that. Or before I get into that, I'll show the diagram here. Sorry, I kind of got off track. So here's the diagram for the setup. Here's the cathode tube. It's just a glass vacuum tube, and then the anode and cathode here in the tube, and then the copper wires are on the outside. They hook up through the tube here, and then that there's a little slit here in the anode for the charge to go through, right? And so this is what the experiment overall was looking like, and that's how he was doing it. And based off of that, he was coming up with that charge mass relationship ratio, right? So originally, the way that JJ thought that it worked was that the charge potential itself was a little tiny vortex, and the mathematics and stuff to describe a vortex on that nature or on that level didn't exist yet. He actually invented it later, but before it existed, that's how they theorized it, right? So the positive and negative aren't about a charged particle and a negative charged particle per se. It's more about a direction of current flow. So the atomic model, we get this thing where it's like we see this physical mass here with the little negative sign, and we think of that as like a charged particle that's, one second. We think of that as a particle that has charge to it, and then like it's a negative charge. Like, what the heck does that mean? It doesn't mean anything. It's a direction of current flow, and this model is just representing that. So if you take that positive and negative of the current flow, it would just make a vortex. So, and that's how they used to think about it. So when they talk about the corpuscle or whatever back in the day, it wasn't necessarily that it was a particle. It was like an ether vortex. It was a charge within the ether. So, and that's what I think it is. So when you get into dielectrics and stuff, this is my interpretation of what happened with this experiment. So this glass tube is a dielectric material, meaning it stores energy. So the area within it is storing energy. So this electron flow that's happening through here, and it's not due to a charged particle disparity of free electrons. It's just a current flow of charge potential. And as it's being mediated through here, through this little hole, it follows a specific path because it's, all built up and it's going through there. So that creates the semi-coherent beam that they get. And then the deflection is just, you're introducing a new medium within that charge potential. So it's just changing the flow of pressure mediation. That's all it is. It's just changing the flow of vortexes. It's not a little particle that's moving around. It's just changing the flow of pressure mediation within the tube. That's my interpretation of it in terms of the ether. So moving on from that, does anyone have any questions about that before we move on to the rest of the E equals MC squared stuff? Or should I do questions at the end? How do you guys
I
feel about that?
real quick, I don't know if you're trying to be live on YouTube, but your audio went out and then it looks like the stream's not going anymore.
Yeah, I just went ahead and cut it off. I didn't want to mess with it live because we're already rolling, so I'll just get it off of Geos. But thank you, though. I appreciate it. Okay. All right, cool. So we'll just save questions till the end then, and I'll just roll through, and then we'll do Q&A at the end.
Nice.
Okay, so this is from a paper from Ives Stillwell, 1952, The Derivation of Mass and Energy Relation. So this is Ives going over and critiquing Einstein's derivation of E equals mc squared in his 1905 paper, and he comes to the conclusion that mathematically he couldn't have possibly have derived that conclusion without through as a consequence of relativity theory without circular logic, right? So this whole charge mass ratio thing with kind of came to a head when Einstein put forward the 1905 paper where he merges mass and energy as an equivalence, right? So this really changes things because in the Newtonian framework, there's what's called rest mass, right? So your rest mass in the lab frame, so this is a rest frame, has to be compatible with all your dynamic predictions. So when you go to model things out, you include actual forces, and you include conservation laws, you have to be able to account for that energy conservation and momentum conservation. And if you're and the way that they do that in Newtonian dynamics is through the mass and momentum, right? So if you're going to say that that's also equivalent to energy, well, then how are you you can't satisfy that, right? So that gets into a more complex nature, which we'll kind of get into at the end of how Einstein solved that. But we're going to go through the history of why people would why people were hesitant to accept the theory and the actual relationship to the charge and mass and that sort of stuff, right? So this is Ives's conclusion here. So Einstein and the work referred to in 1905 did not give this derivation. He did not use the momentum of the radiation, which is an essential element of this example, and his derivation was actually incomplete to give the result he announced. And this is brought to you in the appendix of the paper. So he goes over the more analytical math side of it and shows the invalidity of it. But just speaking about it, throughout the paper, what Einstein was doing was just avoiding a way to describe the kinetic energy of the radiation, because he wasn't able to conserve it. So he was trying to do it. He came up with different angles to solve that. But that's after the fact, years later, because throughout his career, right, this issue haunted him. He tried to properly derive it six separate times throughout 40 years. So we'll get into the history of all that in here as well too. So this is a quote from. This is like a unit analysis of the equation E equals mc squared. So it's like, does this side of the equation represent the units being described in this side of the equation? So energy and mass. So this is an analysis done by J. Thompson in the book The Secrets of Ether. So E does not equal m. Energy is a unit. Mass is a dimension. Energy is composed of a dimension of mass times length squared times frequency squared. So this is the derivation of how he thinks it should be properly defined, since it's not. Since energy is a unit and mass is a dimension, right? So they're obviously not the same. So mass is not, in a unit analysis, right? Mass is not converted to energy, and energy is not converted to mass. Mass is merely a dimension from which the units are constructed. This is repetitive, but the understanding is merely a dimension is perhaps the greatest intellectual, physical challenge for most people coming out of the 20th century. All right, so this is. So it's like, that's a bold claim, Thompson D. Why do you say that? So he further says, we often refer to nuclear reactions on the sun and nuclear power plants and nuclear bombs as example to mass energy conversion. And nuclear power plants in the United States, where they have been operating for 60 years at a high degree of precision, is applied to the measurement for the amount of materials that pass through the reactor. And yet not one report available anywhere that this writer was able to obtain presents data from a nuclear power plant that shows that the mass of the fuel was exactly converted from the energy according to E equals mc squared. One would think that to prove special relativity, that the data from a precisely monitored nuclear plant would provide an abundance of evidence. Nevertheless, no such data apparently exist. And then here, so he says, in fact, there is evidence to suggest that more energy comes out of a nuclear power plant than the mass of the fuel that goes in. A liquid metal fast breeder reactor once operated for 25 years and produced more fuel in its byproducts than it consumed during its operation. Citation 81. So we look into the citation here. So the EBR2 is defined as a liquid cool metal fast breeder, blah, blah, blah. It is cooled with a molten cool sodium metal. Its chain reactions are perpetuated with extremely energetic fast neutrons, and it was designed with a potential for breeding more fuel than it than it consumes. So I went to try and track down the exact citation for this one for the 16-year operation manual. I couldn't find this exact one, but I did find like a cool diagram and stuff of the facility and whatnot. So just like further to the point, like if the exact ratio mattered or whatever, you would think that they would be able to kind of extrapolate that in a physically meaningful way rather than the mythology of nuclear bombs. So here's the facility. The reactor core is over here. You got a bunch of water pumps over here, and then you got turbines here. So it's just cycling water to the hot thing here, and then it cycles that to the turbines, which creates electricity. Very cool. So here's the reactor, and there's the current flow of the water that's running through it. All right. So the Ohanian review, did Einstein prove E equals mc squared? So this is a nice broad overview of the entire narrative of the E equals mc squared and Einstein's derivations of it, because obviously not being able to logically or mathematically deduce it from the 1905 paper is kind of like a stain in the wall, right, or whatever. So Einstein made a bunch of attempts to fix it throughout 40 years, and we're going to go over those attempts now. So although Einstein's name is closely linked and celebrated with the relation of E equals mc squared between mass and energy, a critical examination of more than half a dozen proofs in this relation is that Einstein produced over the span of 40 years reveals that all of these proofs suffer from this mistake. Einstein introduced unjustified assumptions, committed fatal errors in logic, or adopted low-speed restrictive approximations. So what I was saying earlier about the kinetic energy of the system and how he couldn't find ways to do it. So instead of using, so you know how when you're dealing with things at the speed of light, these are relativistic effects, and you have to use your Lorentz transformations and all that stuff. So your boy was using slow speed approximations. He wasn't even using the speed of light. He was using, what they're saying by that is they were using the inertial mass, the rest mass, the thing that has to be compatible with all other frames in existence, right? The frame that we're told now is optional, chosen out of convenience for the math, et cetera, but it's the one thing that clearly has to be catered to. Otherwise, none of this has any physical meaning, right? Otherwise, these math equations are just kinematic descriptions, and they don't have dynamic covariance with the lab frame. So that's what this whole thing is about, especially with when we get into the E equals mc squared, as we're getting into now with these math proofs and stuff, where Einstein couldn't do it, and other people had to do it for him. And then obviously we'll get into the pseudotensor stuff. So let's see. So your slow order approximations. You never succeeded in producing a valid general proof applicable to a relativistic system with arbitrary large internal speeds. The first such proof was produced by Max Lau in 1911 for a closed system with a time-independent energy and momentum tensor, which is generalized by Felix Klein in 1908 so we'll get into that energy momentum tensor that had to, it's like, cool. Like he did this, but like, was it a fool's errand? Is it going to be physically meaningful in the end? Well, we'll find out towards the end here. So further on that, Einstein's 1905 derivation of the celebrated relationship between mass and energy is widely regarded as one of his seminal contributions to modern physics, but he cannot be awarded priority to proposing such a relation. Some years earlier, J.J. Thomson, Abraham, Poincare, and Lorentz had recognized the electrostatic energy in the charge distribution is endowed with mass, and has proposed that all or most of the mass in the electron arises from the electrostatic self energy. So all these guys had come up with different coefficients to explain a similar phenomenon. So the idea that Einstein did it first, or this has to do as like a relativistic effect, is not the case, because if you can't even derive it in the framework, like you remember back when we were kids in math class and the teacher was like, show your work, and you were like, fuck, now we have to like write down on the paper and show how we did the thing. Well, Einstein, not only did he not make any citations in his 1905 paper, which is like, remember when we did book reports and we had to cite stuff? Like none of that shit. So they redefined all of physics on this with no citations and no logical mathematic derivation as a consequence of relativity thus far, right? So we're years into the theory at this point, mainstream, that they had already accepted or like started to accept. So when they talk about the narrative of like, why was there this counter Einstein movement? Do they just hate Einstein because of his beliefs or whatever, or his heritage? It's like, no, man, what he proposed was insane and he couldn't validate it at all. And it took a long time to bury that and change the narrative and redirect physics and not teach people about dynamic covariance with the lab frame and the importance of that, so that all these kinematic equations people just believe in as if they have physical meaning are just gobbledygook. So, and Hasselthorne had shown that the electromagnetic radiation enclosed in a cavity contributes to the inertia of the cavity. So, and that was the guy with the what did I do? All right. So that was the guy earlier with the closed sphere that heated it up and found that the pressure from that contributed to the apparent weight while it was heated. So did Einstein prove E equals mc squared? So who proved it? Einstein returned to Einstein returned to the mass energy problem in 6 other papers, one in 1906, 2 in 1907, an unpublished paper in 1912 that was published much later, and 2 more papers in 1935 and 1946. So, swing and a miss or whatever, right? As they say. These reprises are themselves indication that Einstein had some suspicion that his proofs were unsatisfactory. Didn't Feynman say that one good proof is sufficient? Feynman says a lot of cool stuff unless it goes against the current narrative. And in that case, when Feynman said it, it doesn't apply, and you're just quote mining. All right. So this guy is probably just quote mining. The general proof of E equals mc squared remained elusive until 1911, when Lau finally derived the mass energy relation for an arbitrary closed static system, and that is with the time-independent static momentum tensor containing an electric and mechanical, elastic, chemical, thermal energies of the stress whatsoever. So his proof exploited Minkowski's tensor formalism. It was concise and elegant, and it avoided the tedious dynamical details that had frustrated Einstein. So the Lau integrated the T. This is the old way that they used to derive the stress tensor. So this is what it used to look like in its old form. So Lau integrated the stress tensor component for the energy momentum tensor over the volume of the system and obtained the energy momentum. And he also showed that for the closed static system, the conservation laws of the stress tensor is the energy is conserved, implies that the volume of the integral of the stress is or 0 in the rest frame, blah blah blah, right? So dude, he saved the day, right? He came up with this way to mathematically satisfy a dynamic covariance with a relativistic transformation, right? So from the Lorentz transformation properties of the components of the energy tensor, he was then able to prove that the value of the integrals of the stress tensor components of the energy momentum tensor transform as a 4 vector, and that the total energy of that momentum of the energy system as a 4 vector. So basically, they're saying that he was able to transform the momentum of it and conserve it with their stress tensor. Very cool. So in the last 2 papers, E equals mc squared, in 1935 and 1946, Einstein reverted to his mistakes in the earliest papers. So this again gets into how he was changing the way that he was trying to account for the kinetic energy of the system so that he could make it appear as if he gave a logical mathematic derivation to putting forward the idea that energy is equivalent to mass times the speed of light squared. So in a 1935 paper, which was published by Josiah Willard Gibbs, lectured in the Philadelphia thing. I'm not going to read all this. Let's see. Not going to make you guys sit through all that, but it's just going over on the views with mistakes. So yeah, every time he would do it, he would just keep doing the same thing, right? Because he really couldn't do it in the way that he was trying to do it meaningfully, right? Because it's like, well, why didn't he just use his stress tensor? Because he knew about the issue with the stress tensor that we're going to get into towards the end. So he was trying to come up with a way to do it without that and actually do it in a physically meaningful way where they could establish actual dynamics. Because until now, all these equations, all they're doing basically is just kinematics. It's just measurements. It's just ways to conform a coordinate system, based on constants. And when you have that, you can, and the periodicity of an event, well, you have the freedom to just, express anything, and then suddenly relativity is correct. For example, the perihelion precession, when you get into the complete solution for it, which is done with the Schwarzschild metric, well, that metric doesn't account for the rotation of the sun, the charge potential, or anything real, or any of the energy, any quantifiable dynamic variable that you would have to account for if you were actually trying to make a prediction about the sun that was meaningful. They just approximate it to the sun's mass and then convert that into a gravitational field, which dimensionally may or may not conserve energy based on what pseudotensor you're using. So it doesn't really mean anything in the way that people think it does, because it's like, oh, dude, it predicted it. Well, how's that? If you have the data for the event and you're inputting that and you're contracting that time to like, it's not a prediction, right? That's the epitome of a postdiction, right? So that's why Einstein's theories needed more supplemental proofs than just those observations, right? So just the perihelion wasn't enough. Just the so-called displacement of starlight from the gravitational field of the sun, which we're not even going to get into for this, but just those two weren't enough, right? They needed a mechanism to change the speed of light, or I'm sorry, they needed a mechanism to change the frequency of lights, because Einstein he goes, all right, boys, there's no medium in space. Forget about all that shit. And then everyone's like, okay, I'm listening. And then he's like, here's a Doppler equation, and we're gonna contract the the energy of the light and stuff. It's like, we're not going to talk about the medium. And it's like, what? So, there was a lot of hurdles to overcome for all of this. And this is like extremely pivotal, this mass energy conversion thing, because the mathematics side of it, for the people that, get the mathematics, and I'm not one of those people, right? I'm not over here contracting tensors and stuff. I'm just reading what these people were talking about, what these issues are that were never overcome, what modern people, that analyze the situation are finding out. So these criticisms are still valid, still true, and still ongoing, but it's just not talked about. It's like, hey man, don't tell people that can't do the math that like this shit doesn't work and like we can all just keep going, and that just seems to kind of be the general agreement. So we're going to tie up here on these correctional mistakes here that Einstein makes over the course of 40 years. So 1906. So he analyzes the motion of the center of mass of the system containing several small bodies of electric fields. He introduces the electric field energy in his definition of the center of mass, but treats the contribution of the moving body as non-relativistic and only considers the rest mass. So again, he's trying to prove these relativistic effects, but not even using the proper frame, because he couldn't show the dynamic relationship with Newtonian physics, right? So Einstein failed to. So I just went over it. All right. So strike two, right? 1907, section A. Einstein analyzes the extended system consisting of the electric field and the charges, and he held in a static equilibrium, held by a rigid mathematical framework. So he imposed some further conditions in there to try and create what would appear to be a relativistic derivation of mass equaling energy, and that didn't work either. Tried again in 1907, section B. So he modified the 1905 work by changing the energy of the system and the action of the external electric field. So similar to the other paper, he assumes that the kinetic energy has a simple particle-like form. So in that, he's just assuming that he's just using its rest energy again. So just literally walked in. Like, you ever see someone go through a revolving door and you're like, oh, that dude's gonna leave the building for sure, and then they just don't. They just keep looping. You're like, oh, that's weird. So that's what happened with that. And then so we tried again in 1912. So we're looping through the door again. Maybe he's gonna get out. So the unpublished manuscript written in 1912, but was not published until much later, attempts to explain it as a relativistic effect. The critique here is that it includes the same mistake as the 1905 papers, assuming that the kinetic energy is just a simple particles with the inertial rest mass, without using the relativistic anything, speeds or anything of the mass, right? Because he couldn't conserve it without using that tensor that he told everyone was like a good tensor and it was all cool. But like for some reason he's not using it for 40 years. He's Ein, you have a tensor, bro. You use the tensor. He's not doing it. That's weird. Why? And then his 1935 paper, Einstein once assumed that the energy, he just does it. Let's see. Minimum of the particle has a dependence of the velocity. I can't even remember what this one was. So again, shits the bed. 1946. In his paper again, Einstein repeats the same mistake. Another low order approximation. So those are all summaries from the Ohanian paper, going over the historicity of Einstein's attempts to satisfy the E equals mc squared as a proper relativistic effect. So this astonishing mistake, yes, this is great too. So after all that, right, all those years of not getting it right and knowing about the tensor situation and trying to do it on his own, which I respect, trying to be his own man. So this is an astonishing mistake, all the more so because Einstein was aware of it, but refused to recognize it for what it was. In a footnote in the 1912 manuscript, he highlighted this mistake. To be sure, this is not rigorous because additive constants might be present that do not have the character of the vector, but it seems so artificial that we will not dwell on this possibility at all. Despite this admission, he persisted that the mistake in all his revisions and publications of this argument over the span of more than 40 years. He first wrote down his argument in the 1912 manuscript, included in it several pages on the general theory in his 1921 book, The Meaning of Relativity, in his revised book, in 4 subsequent editions, the last of which in 1955, he never corrected the mistake. So after all those times and all that, he was like, fuck it. Like, whatever, we'll just roll with it. So here's a letter from Big Ein in 1948 to Lincoln Barnett. Einstein denounced the use of relativistic mass as it was being used for special relativity. So in an attempt to, get rid of this conservation issue and bring things back to dynamic covariance, which is the important covariance. Lorentz covariance is cool and all, but it's not as cool as being dynamic with the lab frame. So in the letter to Lincoln Barnett, 19 June 1948, Einstein wrote in German. The letter was typed and sent in English. The highlighted passage in this excerpt says, "It is not good to introduce the concept of mass m equals m divided by 1 minus v squared over c squared times 1/2 of a moving body for which no clear definition can be given. It is better introduced that no other mass concept other than rest mass m should be used. Instead of introducing m, it is better to mention this expression for the momentum of an energy of a body in motion." Oh, no way. So if you don't equate energy and momentum as the same thing, you can just go back to using the old way to be lab frame dynamic covariant. So in 1948, Big Ein was denouncing relativistic mass because the way that he was trying to use it didn't satisfy conservation laws. It actually broke any physical meaningfulness to the theory, and the fact that people were using the pseudo tensor always bothered him, right? Because he kept trying but couldn't get it. And then he was like trying to, but at this point people were like fully invested in it, and he couldn't even stop the train, right? Because he's like, boys, let's just go back to the lab frame. Let's just go back. And they were like, sorry, Ein, we can't hear you, dog. We're time dilating and contracting. Like, they couldn't get him. He was stuck in a black hole. So there can be only one. I forget what that slide was in reference to, but maybe it'll come back to me. So why Big Ein was opting out of relativistic mass. So I kind of just went over the narrative there as to why he was denouncing it. So relativity requires a different value for inertial mass of a moving object in its direction of motion and perpendicular to that direction of motion. This contradicts the principle of relativity that the laws of physics are the same in all reference frame. So E equals mc squared produces non-invariant transformations for inertial mass and energy, which renders it untenable to satisfy the conservation laws on the relativistic scale without supplemental stress tensors. And now we're going to get into the supplemental stress tensors, I think. So on the surface, E equals mc squared appears to give satisfy the conservation laws by let me read this properly. On the surface, E equals mc squared appears to give the appearance of the conservation of energy is satisfied by redefining energy as a function of mass to supplement the logical inconsistency of the theory itself. After 40 years, Einstein did not. After 40 years, what did Einstein bring to the table for deriving E equals mc squared as a relativistic effect? In all of his proofs, the main contention is that while the total energy comprising of both the kinetic and potential energy remains constant, the potential energy can be interpreted as contributing to an augmented resting mass. The interpretation implicitly alters the definition of mass to align with the desired conclusion. So that was the circular reasoning that Ives Stilwell was pointing out, that it's like you can't even get here mathematically unless you already assume what you're doing is facts, right? So induction and atomism. So this is more in regards to the electron situation earlier. So I should probably have moved that slide up. So we're getting close to the end now. So we'll come back to that. So let me write out the momentum on the tensor thing before I fully lose everyone. So Einstein made the assumptions about kinetic energy of the extended systems systems having the same form of a particle without having the solid justification for the proof of this assumption. So without being able to provide relativistic mass derivations, he had to keep using rest mass. So there was no reason for him to say that E equals mc squared. So Lau and Kelvin used conservation laws with the stress tensor TUV to satisfy them. E equals mc squared was mathematically proven with a little asterisk disclaimer. And this little asterisk disclaimer is what Einstein didn't want to happen to his, to be tarnished, associated with him, right? He didn't want an asterisk next to his derivations and stuff, right? So Einstein never proved that this assertion about E equals mc squared without circular reasoning and trying to derive the solution from what he had already assumed to be true. So if we remember back to the mathematical framework of special relativity being Lorentz covariant, adhering to Lorentz symmetry, right? It's not even Einstein's framework. So when he just co-opted the entire framework, like this stress tensor situation was like his only way out, right? Because other people had already realized a charge mass ratio relationship, but they weren't foolish enough to say that was actually changing the mass on that level that Einstein was trying to equate it to. So they weren't down for all that. So we're going to get into what a first order intrinsic differential invariant is. And this is what this pseudo tensor here is. And we'll get into what that means here in a second. All right. So the conclusion here from this paper, I wanted to read off real quick because it gives a nice outro to what we're about to discuss. So this is from Tomb F, Myths Surrounding the Time Dilation in E equals mc squared. The Lorentz transformation equation, as used in Einstein's theory of relativity, are simply the equations of a Doppler effect as applied to a ray, but interpreted as the absence of the medium for the propagation of light, along with the absurd conditions that light is a constant without any means of reference. This leads to the further absurd concept of time dilation, never mind the paradox known as the clock paradox, whereby two clocks can both tick slower than one another. We all know, however, that the passage of time doesn't change its rate according to perspective. When the Earth completes its orbit around the Sun relative to the background stars, 1 year has passed for everyone. So the Lorentz transformation does not actually apply to time as in space, as it would incorrectly be applied to the physical medium for propagation of light, with the time and space variables pertaining to the angular period of the circumference of the tiny ethereal vortices within, or which, according to Maxwell, comprise of the luminiferous medium. The speed of light is determined from the circumferential speed of these constituted vortices. So the speed of the vortices determines the speed of light. So what they were saying here with the time situation, right? So with saying the space is, there is no medium out there, and he just applies it to the radiation, right? So the reason that they had to say time is changing, right? They had to explain the change in the frequency of light without a mechanism to explain why they're using the Doppler effect to change the compression or expansion of a wave to explain that energy exchange without a medium. The time dilation is just a story, which leads to the clock paradox, which obviously has never been manifested, and GPS clocks aren't synced to Einstein's clock synchronization, right? So this is completely unmanifested. This is just some shit that they talk about for fun. This is all just like, oh, dude, if you're at a higher gravitational potential and your twin, and you'll be older than your twin. Like, no, not in any physically meaningful way. Mathematically, sure, but like you'll only see that kind of pronounced effect in movies. Like, what was that one with Matthew McConaughey that had the black hole in it? You know what I'm talking about?
Interstellar?
Yeah. You'll only see like, oh, dude, we're next to the black hole, and then they get out, they go back to the ship, and like your boy aged like 5 years or whatever it was. It's like you'll only see that kind of craziness in film. Like it's not real. It's just mathematical derivations to satisfy conditions that obviously aren't real. Like the space isn't a vacuum. So let's see here. Meanwhile, the equation E equals mc squared does not have the general applicability of mass and energy equivalence as claimed by Einstein. This equation first appeared in its embryonic equation, in its embryonic form. by Maxwell in his 1861 paper on physical force lines in connection with the density and elasticity of the luminiferous ether. In simple, it is simply Newton's equation for the speed of a wave in an elastic solid. The realization was noted in more recent times by Dr. Minami Samuel in connection with the binding energy, and is explained in the 20th and is explained in his work, the mass energy equivalence deception, the greatest deception in the 20th century physics, and elaborated in section 4 of the double helix theory of the of the magnetic field, and in an article about pressure, radiation, and E equaling mc squared. The E equals mc squared has never arises unless electromagnetic radiation is involved, whether it be black body radiation, X-ray, gamma, etc. These equations apply neither to the radiation itself or to the wave propagation medium, as it is the very same luminiferous medium that Einstein discarded and the greatest acts of scientific vandalism ever performed.
Wow.
So if you want to get real familiarized with some dense material, if you want to see like what it means to like contract a tensor and apply conditions to it and do a transformation with it and all that, and then like show that it's that it's not an invariant transformation and that it breaks covariance. Check out this video here. I'll have it linked in the description. Oops, not going to play it out, but it's a 18-minute video. He goes over the math, breaks it out, goes over the history of it, contraction. It shows the issue with it. So this issue about the stress tensor, how it's a first order intrinsic differential invariant. That issue was pointed out, long ago in the past, and it's just kind of not something that's not really talked about. Some new tensors are put forward that are said to satisfy the conditions properly, but they're actually also they also suffer the same fate as the original stress tensor, because your boy Stephen Crothers here did a similar analysis on those and found that they're all just the same thing, because they're all derived from the same thing, and it's not. You can't do that once you violate the structure of the mathematical framework. It's no longer valid as a physically meaningful as to say something like, oh yeah, the space-time curvature is why that's doing that. Like, no, that goes out the window when you break covariance within the mythology of Einstein, right? Because the covariance is like the one rule that they have to apply to, or that they have to adhere to. So I got some slides here to give some supplemental definitions if you guys want to go and watch the Crothers work later. He doesn't really lay out what the words and stuff mean, so kind of did some definitional work here so you guys can go over covariance, invariant transformations, the tensors, the pseudotensor. So an object that's like a tensor, but it's only invariant under certain coordinate system transformations. So it's not, doesn't mean anything. So the first order intrinsic differential invariant, I have it typed backwards here. It's differential invariant. So is a type of invariant tensor that is coordinate dependent and changes under transformation. It is composed solely of the components of the tensor and its first derivatives, and it is not derived from the field equations themselves, and it cannot be obtained from the second order field equations, which violates the mathematical structure of the theory based on the principles of covariance and the idea that the physical laws should be independent of the choice of the coordinate system. So if you guys remember back to Einstein's first postulate, all inertial reference frames are equally valid. So that's called Lorentz symmetry, or Lorentz covariance. So any transformation within using Lorentz equations, the gamma corrections, all of those should be invariant transformation. So the speed of light, the laws of physics, all of that should be invariant under transformation. So anything that's a law of physics, so F equals MA, that sort of stuff, is it going to be the same in this reference frame or that reference frame? So all of that stuff is validated, one, through the mathematics, and then from there, it's a hypothesis waiting to be experimentally verified. But for mathematics' sake, before you can even pretend that it has any meaning, the covariance has to be established, right? So that's what all that's getting to on the analytical side of it. So it's a really interesting subject to get into on that side of it, because it really exposes the nature of what's going on here. Because it's like, how do these equations make these crazy predictions, right? It's like, well, are these predictions dynamically covariant with anything? Like, do they mean anything? what variables are they accounting for? When you whip out a Schwarzschild metric in your perihelion procession, what actually are you accounting for, right? And it's like, oh, so this isn't dynamics. This isn't physically meaningful. This is a role play. So I think that's the end of the slides there. Yep, I think that's it. So we are now open to the public.
This is the role play. It's just a live action role play, guys. Everyone go home. It's all set. Dude, that was awesome.
Thank you, sir.
Then I don't think I have a question, but like a contribution, I guess, in the form of corroborative observation and akin speculation, perhaps.
Mhm.
So, like, when you think about what Robert Bennett was talking about on What's It Show, when his onslaught on relativity, with the experiments that he brought up that tried to prove relativity but always failed and mysteriously worked when you accounted for a stationary Earth and a rotating ether, and when all the measurements would always come back to, well, in the lab frame we can measure it and then we can translate it to other reference frame coordinate systems, but it always comes back to like theta prime or the original reference frame, the only one that matters, right? The stationary Earth frame. And that served as like insurmountable barrier for furthering heliocentric lore mathematically and scientifically for a while, until Einstein comes along, right? And when you think about it, the ramifications of that E equals mc squared, like, it's astounding. If like energy equals mass and mass equals energy, then like if lab frame has always been fixed and at the center and no measurement can be made outside of this, like, till Einstein made it so all frames are equal, this is like devastating to like rationality and the progression of where we were going, and essential to their obfuscation and then like deviation down nonsense road. By saying mass is energy and energy is mass, he invented like coordinate system transforms that would like obscure truth later and be used to do the coordinate systems and the obfuscation of true coordinates and the satellites and the shit that you've been working on. And then they had to adopt like Lorentz contractions to explain the excess when converting between back and forth in the coordinate systems between like ECEF and ECI, as Bennett was going over quite coherently. Because in reality, you can only make measurements in the lab frame, which can never move. So like, even when you mathematically describe how you can translate the measurements in the lab frame to different lab frames using E equals mc squared, it's kind of like a backhand way. He simultaneously invented like not only the send science down the system of relativism, but a system of relativism that leaked from math like into science and then philosophy and then religion and then eventually morality. Like, the most devastating hit is like that literally led to moral relativism peering into every aspect of human reality, and was probably the biggest like stride forward towards the mathematical construction of a world of heliocentricity that there ever was.
Right. Like, they didn't even need any of that shit. Like, special relativity in that time span broke physics, basically. I mean, they just desperately held on to their model, and then they don't even, like Alan just showing, they don't even use any of that shit. And then the science that's progressing today, like quantum physics, they basically just renamed the ether physics. I mean, y'all heard it, the foam, the freaking, all the renames of it. But yeah, they just basically slam brakes on science, man, in my opinion. And it found a way to progress on its own, but that shit didn't apply to nothing in our reality, basically.
But it's stuck.
Well, they found ways around it, man. But I appreciate all the work Alan's doing, man, and kind of picking up, man. I appreciate you giving me credit too. All I did is go back and look at and pulled up the Ron Hatch and made a little video in Austin and ran with it, and then Alan really ran with it, dude, and he's broke it open like
Oh, dude,
open, man.
Dude, so check it out real quick. Let's go over the ECI reference frame and the significance of the ether real quick. So you remember my boy GPS. So actually let's tee it off with Wang real quick, and then we'll get into the actual documents. Is this the right one? Fingers crossed. Okay, cool. So contrary to the appearance of the range measurement, this is Wang 2000 whatever. So contrary to the appearance of the range measurement equation, the speed of the receiver V does not appear explicitly. The speed of the receiver is implied in the definition of the position of the receiver. The composition of the position of the receiver at reception time compared to the position of the stationary receiver at reception time, the position of the moving receiver and the reception time is different, and the difference is proportional to the speed of the moving receiver. How could it possibly be proportional to the speed of the moving receiver unless there's a mechanism in which all motion is relative to some sort of etheric background, perhaps? But we'll get into what that means exactly. So it's like, okay, well, maybe there's some correction after the fact, maybe blah, blah, blah. Okay, no, cool, maybe. So here's the ICD documents from 1994. Let's see. So this is how they used to word it, but then it's a little obvious this way, so they change it in subsequent documents. So this, and we'll get into the change. So this is the way that they used to say it, 1994. The Doppler shift of the frequency of the received carrier signal is proportional to the relative velocity of the receiver with respect to the satellite along the line of sight from the receiver to the satellite. So what they're saying here is this Doppler shift mechanism, there's a frequency, the speed of light is changing proportional to the velocity of the receiver, is what they're saying. So here's how they show it in modern. Yep. Here's how they show it in modern times, real quick. So they give you this cool diagram. They talk about GPS time, the time the signal was sent. It's encoding all your relative coordinates, all that stuff. And then blah, blah, blah goes in through a filter and coordinate converter. And then the output is the user position, velocity, and time. How did you get the velocity correction, do you ask? Well, it turns out that Wang's paper is all predicated on telling us exactly how GPS works. How does GPS work, Wang? So GPS is a successful operation based off of a range measurement equation that uses an ECI reference frame. What's the ECI reference frame, you ask? This is a stationary non-rotating reference frame, but what they really did is equate the rotation of the Earth and make it equal to the rotation of the stars, so that they would be rotating together. So they have this measurement where the speed of light is actually C, the way that they intend it to be. But then they have this leftover remainder. So what do? They transform to the ECEF reference frame, which is where they say we live, the rotating ball and all that stuff. But that's just a map coordinate system. It doesn't mean we're on a ball. It's like, relax, guys. So they take that and they with that transformation, they have that remainder left over. That remainder left over is the velocity correction that they have, which would completely, if they didn't disguise it in this way with the transformations, the original measurement would be a complete invalidation of special relativity on the face of it, because the speed of light would be changing proportional to the velocity of the observer, and there's no mechanism for that in relativity theory, because the ether is superfluous or whatever, so it doesn't exist. So there can't be a background medium. So the same way that like someone going through water and sonar propagating through it, right? There would be a delay proportional to the velocity of the person through the water, right? So that's the same mechanism. What's doing that for the electromagnetic propagation from the satellite in space, right? It's the ether, guys. So that's what this whole situation is about. That's what the ECI transformation is what it covers up, because what we find out here through how GPS works, it being a time interval system based on a range measurement equation, that first measurement taken is a first order measurement that's accurate down to the millimeter, that should be applicable to any coordinate system under transformation based on them all being synced at the same time. So there should be no reason to even there shouldn't even be a velocity correction in that. It shouldn't work that way. So
it's unnecessary. It's a death nail, bro.
Right. So that's what we're talking about, right? So that's all these things have been known. These barriers have been put up. Science has been done. Rational minds have prevailed. And then Einstein comes along, does some mathematical nonsense, bogarts some mathematical equation, says actually E equals MC squared, and things contract and you can't dilate, but actually you can't detect it or measure it or see it. And now we're going with that. And so we have this like degrading system of moral relativism as a direct result of his ridiculous appropriation of nonsense, like previous mathematical concepts that weren't his, to try to describe and appropriate things that in his dynamic system he's never accounted for, because it's always just been a kinematic equivalence mathematical nonsense description.
It kills me when they say, "Yeah, you have GPS because of Einstein and shit like that, bro." And even with quantum mechanics nowadays, they're like, you wouldn't have cell phones or any of that shit. Like, dude, the transistor came before the mathematics. They invented the shit, and then did the mathematics kind of, they used that to upgrade shit. But all that unnecessary mathematics, man, with SR is a joke, man. It's like, dude, we still have all that shit. They act like the math came before any of the inventions. As far as pinning it down and maybe making shit more efficient, then the math comes. But if it, the transforms are really, I don't know, man, unnecessary. Just a bunch of unnecessary. When you hear
Dude.
transform, if it doesn't have anything to do with the inertial frame of reference, it's bullshit.
Wasn't there a quote in there of like, it's like the most insidious deception known to like science or something? The way he described E equals
scientific
Yeah.
vandalism.
But, like, so the way that was so eloquent and beautiful, but really, like, it's the most devious thing to try and say everything is equal. Like, this one reference frame that's always mattered, the way we can take measurements and do things and make predictions. That's the only one in reality. That's, the Earth-centered, or Earth fixed, no movement. But we can translate it to these other frames and tell you the Earth is moving, but that one is the only one that matters, except this dude came along and made it so nothing matters, everything's equal, all reference frames are just as valid, therefore nothing matters, and, nihilistic, like, ploy. Dude, it's like the most devastating thing to ever happen, I think.
Dude, and then didn't even do it within the validity of the mathematical structure that he proposed, right?
No, just
like,
said he did
that's
it,
how you
and then didn't justify
that's
it.
how you that's how you know how propped up this stuff is, because your boy came through with no citations of the theory that adheres to another guy's namesake for symmetry, for transformations. And it's like, did you cite him? No. Dude, he says that he came up with it before he even heard of that guy's work, even though we have like the private letters to his wife where he was like, yo, Lorentz is working on that new transform, dog. I got to get in there and see what's good. Like, what the hell happened, man?
Dude, he just
Like,
said some stuff.
Like, we just let this ride for so long. And it's like now all these bright minds go into these math equations and they're like assuming relativity is correct, and they force the correctness out of the mathematics through a framework that's structurally compromised, right? That has no validity to it.
Had to keep that Earth moving. They had to keep that Earth moving, man. They couldn't stop that by no means. But just flipped everything.
So that means like
Ridiculous.
Einstein's contribution to like this to deter us from the truth, to keep us buried in nonsense, is like the most monumental one throughout history.
Yeah.
Dude, everything they've done to keep the Earth moving, it's like, they do the test, the test.
Yo,
one
one
right
second,
there,
Brian. Let me go over something real quick.
No, sorry, go ahead.
Yeah, you're good. You're good. So in this letter here where Einstein's like, yo man, there's no clear definition of like a mechanism for this equivalence, like, sorry, like let's abort, right? So he used that same criticism against the guy that he ripped an equation off of to explain the perihelion precession in his first derivation. So the Paul Gerber controversy. So Einstein, let's pull this up real quick. So where was let's see, Paul Gerber. Yeah. So he stole this dude's equation right here. So this Paul Gerber guy came up with a mechanism for how he was explaining the propagation of gravity through light, basically. So he was tying the speed of the propagation speed of the gravitational field to the speed of light. So he was saying that light was the mechanism by which it was, propagating through, right? So that was his explanation for it. He has a full mathematical breakdown thing. You can pull it up. It's called it's not cited here. It's called something gravitation. But anyway, he has a full framework for how he got here, right? For this equation. And then Einstein comes in with this suspiciously identical equation where the only variable change is he has a capital T, and instead of saying that the speed of the gravitational propagation is tied to the speed of light, he's saying that T is the periodicity of the of Mercury's orbital period, right? So it's just a kinematic prediction, right? It doesn't have any actual validity to it, or it's not dynamic or anything. But it's just like they just changed this, contracted the time of the orbital period to get the precession, and that was his mechanism for it. And he's going to criticize this dude, or so this is how he hand waves dismiss being accused of plagiarism. Einstein says, see, if this guy wants to make us believe that the perihelion shift of Mercury can be explained without the relativity theory, so that there are two possibilities. You either invent the interplanetary mass or you rely on the work of Gerber, who already gave the right formula for the perihelion shift before me. The experts are not only in agreement that Gerber's derivation is wrong through and through, but the formula cannot be obtained as a consequence as the main assumption made by Gerber's work, and therefore is completely useless and is an unsuccessful and erroneous theoretical attempt. Oh, no way, Einstein. So if you can't show your work and it's not fucking, it doesn't work out the way you say it does, and you have to make a circular logic to force your math into it to get to make something a consequence of a relativistic effect, you're saying that makes it invalid. So let me read this again real quick. It says the highlighted passage in the excerpt says, it is no good to introduce the concept of relativistic mass, where m equals the change of mass relative to the speed of the body. For there is of a moving body for which no clear definition can be given. It is better to introduce no other mass concept other than rest mass. Instead of introducing m, it is better to mention this expression as the momentum and energy of the body. Cool. So no clear definition. It's a completely useless and unsuccessful and erroneous theoretical attempt. Got it. Shout out to your boy Paul Gerber, who gave it a solid attempt to explain the perihelion precession through Newtonian dynamics. He gave it a good try, but you know.
Dude, when Bennett was doing his thing, like he went through like, I don't know, 12 or 13 different experiments where relativity failed utterly, and a stationary Earth with a rotating ether just, it worked perfectly, and it's just weird.
Alan, props on that, bro. That was awesome, dude. And he broke it down, like really, really broke it down. And from what I understand, you contacted and reached out to that guy, and he had a real open mind, man. He a big, massive shout out for that, bro.
Yeah, dude, he was like the sources that Alan was researching for the shit that he was looking into, and then one day he just like the interview reached out, he showed up in chat, and he was like, "Oh shit, is that you? Are you the Robert Bennett that wrote this paper that I'm reading? What the fuck?"
Dude, he subbed to me on YouTube.
Nice.
I saw the sub pop up, and it was like Robert Bennett, and I was like, "No way, that's dude from this paper I just read." And it was
funny feeling.
And he was looking for he was interested in the ether dynamic stuff that I was reading. He was trying to get an English translation of that Atsutovsky book, because your boy has got the first English translation of it.
Did you translate it all by AI and then give it to him?
Oh, absolutely. In that order. Yeah, there's this really cool AI called let me pull it up here. So it's really awesome. So it's you sign up for like the ultimate free edition, or I'm sorry, the ultimate premium edition of it, but it's free, no charge, and you cancel within 30 days. They don't charge you. So you just sign up with a valid credit card and all that, and then you cancel it immediately, and you can translate up to 500 or 5 million. What is it? You can transfer up to 5 million words or characters or whatever at a time. So basically that book was 625 pages. So I was able to get like over half of it, translated with just one, just in one attempt. So it's like, it's awesome.
That's a word. Yeah, that's a word for every Wang experiment, man.
Yeah.
No,
for Miller, but yeah. That's a word for every Miller measurement, dude. Exactly. So yeah, we have the Faraday induction generator where the lab frame makes the correct prediction. That's cool. And then so this ether vector thing is awesome. I kind of started dabbling in this a little bit. So get this, Shane, you'll like this. It involves electron interferometry. Do I have your attention yet?
I like that.
Electron interferometry. Very cool. So what they have here is a solenoid which produces a magnetic field within this wiring, or within this tube structure. So they say that mathematically speaking, outside of the tube structure, the magnetic field is basically zero. Like it's not even anything that you would ever consider, blah, 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 right? So they hit up your boy with an electron wave, and they find that there's an interference pattern produced. So what they've determined from that is that there is a vector potential, meaning that there's a force that exists outside of the generation of the magnetic field that's generating the magnetic field. And that's what they proved there. And so they kind of co-opted that as like a quantum blah blah blah, situation. But like,
Wait, wouldn't that like
obviously,
disprove the self-perpetuating field that they have since invented, though? Wouldn't that
how
be the
dare
opposite
you?
of that?
How dare you? So there's that with it, and then when you get into the mathematics of it, so if you know the vector potential, you can describe the the divergence and the radial change. So like the size of the toroidal and the convergence of the the toroidal field. So you can figure that out if you have the vector potential. So the vector potential supersedes the other two potentials that you would have to use to figure that out, right? Because you could derive it doing some other, like, I don't know the proper terminology, right? I'm still learning it, but this is like the basic rundown of it. So mathematically, the vector potential the background medium that's giving energy to the thing supersedes it mathematically, because if you have that, you can derive the size and curl of it. Very
So,
cool.
Alan, would that
Oh yeah.
would that apply to like DC generators, like the fields? Like I took one apart. I'll make this real quick, and it's like you have the coil, and then you have other coils. There's no magnets in there, so they don't have to claim magnetic fields and anything. But what are they claiming? Like the stagnant coils are just electrons are just bouncing around the whole time. There's obviously a field present within. Is that what you're just describing apply to the reality of things like that, like like home generators and gas power generators and shit?
So anything that
Or
generates a
myself,
magnetic field what does this? Like the vector potential comes from anything that generates that. So anything that does it.
Was that what Bennett was talking about with his like loop formula when we were going through it, and then we had to stop because I had no idea what the hell he was talking about, and then we've both learned that. Now you've understood it. Nice. Okay.
Yeah. So this is the follow up. So yeah, I watched a couple videos on the experiment to kind of see what they were
Nice.
doing. I linked some in the King's chat. So if you scroll up, you'll see a really funny thing they did. So there's this channel called 1 second, scrolling up to get the name. He's a cool channel. It's called the Science Asylum. He does some pretty cool videos, and what he says at the end here, he's like, 1 second.
Yeah.
So at the end of the video where he's talking about this, god dang, that experiment, he goes, in regards to the field that's not supposed to be there, that because it exists there, he just goes, oh well, it turns out there's a field there, so that explains the fringe displacement. Thank God, everything's solved. And it's like, no. It's like no. There's not supposed to be a field there. Not everything's solved. So like, yeah, it was just interesting. It was interesting how they co-opted it, because he was like, woo, we were about to refute the whole model, but whew, turns out there's a field there, so we're all good. It's like, no,
it's okay. It's okay. We found this energetic background that makes everything work, but we'll just discount it completely. No, everything's fine.
Yeah,
Crazy.
essentially that's the flaw in most of their conversations, right? Is they, what you don't know can't hurt you, essentially.
I got one more question for you, Alan. Is it possible that like Wang, like when you reached out to Wang a little bit, and he kind of, is it possible that like somebody like Wang and a couple others like him, we're just looking at the experiments themselves and going against mainstream science because they never really followed it out to the logical conclusion, like what it means for the Earth and all that, and they were just looking at reality. And then like when you go to reach out and you kind of mentioned some of the implications and all that, like is it possible that he never really thought it through and he's just going based on reality and what the experiments are showing, and now he's like, oh shit, is that possible? Like why he ain't responding as like he should be, kind of, man? Because you're promoting, not like Miller, Wang, and all them. Is it possible they just really never really thought about the logical conclusions about what it means for the Earth being in the center and the inertial reference frame? I mean, have you thought of that yet? What do you think?
Nah, I didn't think of it yet.
Well, so that's what a lot of the esoteric teachings, that's almost the heartbeat of it, right? It's just the mystery of the mystery of the mystery that can go on forever, right?
Well,
and
dude,
but
Wang,
there's got to be an end. But yeah,
Wang wasn't part of the dude. Like he he understands the ramifications full well, and because of the pressure that some delving into down that side, he decided full well to not do that. Just stopped and just like ceased
Well,
contact.
yeah,
So
and sometimes
when Alan
there's
asked him
not enough
questions,
information.
Retired now, though, right?
when Alan asked
Ain't he
him questions
retired?
regarding the ECF, like he was just like, "Oh, no more answering after that." And Bennett kind of sniffed him out. So what you got to think is like Bennett's retired and can talk about it without repercussion, but Wang's in the field still publishing stuff, and if he
Okay,
sides with it,
gotcha.
then he can't publish it anymore, and he just decided no.
Okay, I'm
Yeah, and
with
a
you
lot
now.
of that
So
can end up
he's
being
still out in the field
subconscious.
then.
Oh, go ahead.
Oh yeah, you didn't know
It's a
that,
damn
Brian?
shame, dude. It's a damn shame, man, that they, what was that, Al?
I said, oh, you didn't know that he was still working,
No,
Wang?
I didn't know
Oh
that.
yeah, he's still at the University of Minnesota. So
Yeah,
he
so
was. Bennett said that he kind of alluded to the fact that he was like, not willing to pursue it because he was afraid that it would interfere with his career.
Oh, which program is he in? I live in Minnesota.
University of St. Cloud or whatever.
Oh, okay.
St.
Up
Cloud,
there.
Minnesota. Oh, hold
Yeah, I'll
on,
have
it's
to
right here
look
at the
him
top
up.
of the paper, boys. Here we go.
Oh.
St. Cloud State University, Ruyang Wang.
Yeah, I mean that's the popular engineering one of everything. Just
Yeah.
for cheaper, realistic engineering. That
But
was my
yeah,
college.
here's what I speculate about Wang and what he knows or doesn't know. I think he knows about the ether. He does a good job of breaking. He's explaining here this situation with the that there's a what's it called, that there's a proportional situation going on with the variance and the speed of light, and then he goes on to make the comparison of sonar propagating through a wave and giving that context to it. So it's like when you think about it like that, it's like, well, what is the electromagnetic propagation going through? Seems to
Well,
be
and to your point,
it seems
with
like he kind of alluded to the ether.
yeah, and
In
for
my
a
opinion.
career kind of perspective, the only people in the world right now that are reasonably doing experiments on a large enough scale, literally the size of the Earth, joke intended, to actually get that variation, to actually get statistical significance and all that, then potentially get published, but then it's all in the military's hands. I think a lot of it ends up in that kind of loop, essentially. Whether these people consciously or subconsciously are,
Yeah.
blocking
Well,
things out. Yeah.
Yeah, no, absolutely. Because it's interesting you mentioned that because Wang, one of the experiments he did in 2004, this fiber optic cable that he used was given to him on loan from the military. I think it was like $5 million or something. It was like some state of the art fiber optic
Yeah, it's
coil that has
expensive
like
materials.
a refractive index of 99.999999999 or whatever. It's like the speed of light can just really rip through that bad boy. So this is like the most accurate thing ever measured at the time, and it just like completely falsified relativity, and it showed that only the lab frame makes the correct prediction, because he also had a conveyor here that was held up by air, so like that frictionless bad boy just dragging along with the conveyor motion, and it doesn't work for relativity in the way that they say it should, because it's doing linear motion. So it's like he falsified it to a crazy degree of specificity. And then when Bennett hit him up and was like, "Yo, you trying to follow up on that and really zip that body back up?" And,
He was like, nah.
Wang was like, "Nah, no, I don't want to do that. Like, I'm
Thank you,
out."
no thank you.
And that's crazy, because if you read Wang's papers, he's got a whole collection on ResearchGate. He's proposing like these like intricate experiments to falsify relativity with GPS. He's like, look, we can settle it once and for all. Like, he sounds like he's like in the papers, dude, like he's about it, but in his career life, he's like, nah, man, Einstein's legit. It's all good or whatever. Like, let me get another fiber optic cable to hang myself with. So,
this reminds me. There's so how there's the idea of the great filter and stuff like that in outer space. I mean, it applies to inner space too, but with the kind of unseen, the unveiled things, I've noticed a lot of times popping up like gold being diamagnetic. No coincidence that it's a highly sought after, highly overpriced metal. Just stuff like that. And I think I was even calculating out like what the frequency would be of consciousness based on what some anesthesiologists discovered. and then I find out that all the calculators don't go past that, kind of calculation typically for like literally number of digits and good stuff. But I don't know. It's like there's a bunch of like limitations of measurement systems and stuff that aren't really intended, but they just kind of linger on, and until we put pressure on them, like stuff like this, where there's obviously an ether because there's a fluid below every level and above every level, right? It's just, whose toes you're stepping on, and is it actually going to do good to bring it out to the public and stuff like that.
The military's got to be using some of this ether technology, though. Like the compressed air technology, like with the turbines for compressed air to get more air going to the fuel. Fuck that. Like, why don't they use this same type of technology to have coils spinning, have this fast ass air moving, and kind of like a DC powered, a gas powered generator. Like you just have the coils spinning that already have a magnetic field. That propagate a field that excite the main coils, and they'd have like quadruple the energy. I mean,
it's a real nuclear reactor.
That's probably what they're actually using in the drones that are flying around and shit, man.
Oh yeah, and I think I've noticed a trend too, where a lot of these technologies, like where you could probably cancel the inertial mass of an aircraft or whatever you want, right? I mean, I've literally watched people on YouTube do it. I've watched people stop light on YouTube. I mean, they're just legit filmings and stuff. But I think when military develops the technology and it's literally written in laws, if they don't have safety around it, it's kind of their liability if they end up releasing stuff to the public and, they're in they knew they have data that it's not safe in certain ways. And a lot of that points back to that. As far as stuff they're actively using now, right, that we see, and it's like, this obviously doesn't jive with stuff we normal people use. Kind of like you're saying,
literally have one turbine and really spending nothing, just whatever it takes to get it up and running, and running like two other turbines or maybe even three, just off the electric energy produced from the damn one. I mean,
and I'm sure you've seen the Mercury stuff where there's the whole stigma around Mercury because there's money in it, right? If you can control the market, again, silly control the market money games. But I mean, you could even touch Mercury, but sure enough, there's all these designs where you just spin it really fast and let it keep going. And the dielectric properties, along with the inertial, momentum you're creating with that, you can do all sorts of things, right? If you literally just go build the diagrams you see on any weird, sketchy website that somebody's found over time.
Is Mercury dielectric?
Sometimes no, not dielectric, but I meant like interactions with the electric field. I watched too much.
No, yeah, gotcha. I was just like, I was like, oh, no way, that's crazy. Because I just started learning about dielectric stuff. Anyway, what were you saying, Shane?
Are we done with the equals MC squared thing?
Oh yeah. If nobody else has any questions, Gio, we could probably wrap up. Obviously, I'll stay, hang around for a little bit, and if anyone else has any additional stuff. But if you want to switch it back to the normal station programming, I'd go ahead and wrap it up or whatever.
Man, that's a great presentation, man. It's always so thought-provoking, man.
Yeah, that's been one of the topics I've been trying to kind of wrap my head around, just kind of the speed of light moving and pretty much all those experiments you're talking about. I've never heard of half of them. So it's really eye-opening.
You should watch Whitsit's last In the Field with Robert Bennett. He brought up 14 or 15 corroborative experiments of the same, all with the same conclusions, astoundingly coming to the same conclusion that the rest frame is the only one that matters.
Yeah, it's not surprising. All the guys in the history books that are tied to any of these experiments, they're always in the Royal Society of London College or some weird secret society in their family. So, yeah, it's probably hard to find them. But, yeah, I'll have to look that video up.
But, yeah, dude, I don't know if, Come Get Squared would describe it or, the great philosophical and insightful ramifications of the E equals MC squared equivalency. I think that would have been a better title.
I'd look key.
Oh, yeah. Yeah, I like the philosophical ramifications of getting squared up.
Okay, that's a happy compromise. It's actually cool. That should be the name of the second one.
Yeah, I'm changing it right now. The title.
Nice.
Oh, oops, shit.
Yeah, I was very baked for that whole thing, so that was great.
Me too. I fucking ripped up right before we went live.
Yep.
Dude, I was so high I couldn't fix my volume on my
dude, I was very surprised.
Which I know how to do immediately. Yeah, I know how to do it immediately. And I was like, fuck it, abort.
Yeah, I know. Dude, like one thing, you're like, just blow up the whole thing. Like what? Hit unmute. No, fuck it. All right, fuck it. It is. Yeah, man, I re-up my pack squads.
Well, this time, I started it right at the beginning, and I had it like open on my second screen pretty much the whole time to make I made sure it was up the whole time, so that was a good timing.
Nice.
So I think the previous times I might have started it like a little late or something, but yeah, this one should be like fully covered. There's like probably no interruptions of the screen share too and the audio, so yeah, it should all be clean from beginning to end.
That's excellent.
Yeah.
You're gonna have to steal that and upload it now, Al. That's the sole surviving copy of the rendition of what you just did.
Oh, bro, I take all of them and upload them and tag Geo in them.
Nice. Dude, your YouTube channel's doing nice now, huh? You're almost over 1,000 now. That was relatively quick. It seems to be just the other day. You're like, "Hey, I'm going to start a YouTube," and here it is. There's like 7 subscribers.
I had like 80 subscribers at the beginning of the year, bro.
Right?
The 80-piece nugget.
Your gold cratters are in his eye, by the way.
Where'd Matthew Learns go? Wasn't he in here? Weren't the Globers in here? There were Globers when we started, right? Globers came in and out during the thing. I heard the dings.
I'm just happy that
They
had to check back in with the CIA.
Like since Kosho was here.
I think Matthew got bullied out of the chat. It looked like.
Yeah, I was leading. Yeah, people like to bully Matthew.
Yeah, it's unfortunate, man, because he's a nice lad.
But that good this was like you got to let Matthew Learns critique you guys, or you guys are just grandstanding and peacocking. It's like, dude, it was open. We wanted the Globers. I called out the Globers before. I think I commented, boy, I hope they stick around for the end so we can ask questions. And then the end came and went, and none of them asked any questions. And what the hell? I was welcoming it, dude.
Yeah, you did jump up quick on subscribers, man. Passed me up. I went. I kind of tied the noose myself, man. When I called out and made all the videos with Quantum Eraser and Nathan Oakley and junk, man. Like I lost a lot of subs, but man, I gotta call it how I see it, man. You know, I still watch them.
It's just the ether divide, dude. It's weird that like everyone who's not on the side of the ether is like, you know, super angry and ornery and has a terrible like negative like a perspective on everything. That's a weird like differentiation.
There's a neutral way to stay to keep them all. You know, if it's just about subs, because I didn't really lose any because I gained a bunch, but I lost a bunch. And but I mean, I could have just been neutral and gained a bunch if it was just about subs. But man, I'm gonna call people out. I'll call myself out. Shit, if I catch myself in something, man, I'm gonna call myself out. I've done it before in videos where I had to, man. Just keeping it real, man.
Dude, I think I saw Witsit pop in for like the tail end of your presentation. I haven't seen him on in a while.
Yeah, I saw him on there for a second. Wanted to say what's up after the.
Yeah, it's like I
thing,
saw
but
him,
you did.
and then I like meant to go like talk to him, and I was like, oh, he's gone already.
Do you?
So yeah, the Globers are all left because they're going to go huddle, review the information, get their dissemination of their script from MC Tune, and come back into the text channels.
Yep. Until then, see, now that it works there, dude. It works there. But until then, like,
tuned up.
Yeah, dude. Until then, like, they're either gonna say nothing or they're gonna pull the dogs are gods thing and just randomly start like inserting their juxtapositions, like Google says stuff. No.
Yeah,
The
but there's
better.
always going to be one, two of them though, man, that come across this and they're like, "Hey, how come why didn't I learn that?"
No. They
Whether
don't
they
think
think it or
that.
not. How come I didn't hear about any of this? Oh, I ain't talking about Matthew or Crochet with them, but you know what I'm saying. People who are just feeling it out and seeing what's they've got to ask the question: why wasn't I taught this? Why didn't I hear about these conflicting views and these other experiments? Because they're getting harder and harder to find. That's why I think Alan's doing a good job of bringing all this right to the table, man. Throwing it out there, man. It's important work. Bringing Bennett, dude. Bennett. That's like insane, man. And
Yeah, that was epic, dude.
didn't
You know what could be
didn't you have
also
a
epic
couple
is
back and
when.
forths with Wang at first?
What?
Didn't you have a couple email back and forths with Wang, or did he just never respond? Period.
No, I emailed him originally saying, "Hey, I'm interested in your paper. I just wanted to confirm that this is the correct or that this is like a valid." Sorry, excuse me 1 second.
Yeah, so you started referencing like the specific center ACI like implications. He was like, "Oh no, never mind." When he was like, "Yeah, I'm interested in your work and this is cool," he was like, "Yeah, that's great." Oh, ECI? No, I'm not interested.
Yeah, so yeah, sorry about that. So I'm like, yeah, I'm interested in your stuff. I just want to make sure this is a valid email address. And he emailed me back within like 20 minutes and was like, "Yeah, super valid. Hit me up, dog. Can't wait to talk to you. It's going to be super cool. Love answering questions or whatever." I'm like, "Great." So I didn't want to waste the opportunity, right? So I didn't hit him like right away with some dog shit. So I was like, cool. So I'm going to like study up now. So I like go in depth, and I come up with something like I don't want to freak him out, right? Because obviously we have wildly different views on cosmology that would affect his career if he got caught, associating with the enemy or whatever, right? So I was like, just trying to bring it up casually about some questions I had about the ECI reference frame because it always bothered me why they have to transform in the first place if it's valid in any coordinate system. I mean, like what the hell's going on there? And then so I asked him about that, and then like before I got to that, he mentioned in one of his papers that that there's like a dispute in the academic community about Einstein, and that like it's a highly debated topic on the accuracy of the theories, and that his GPS proposal would settle and stuff. So I asked him about his experience with questioning Einstein and like not being an Einsteineer in mainstream academia. And like, so those were the two questions that I asked him, like, about the Einstein stuff and how that was like, if it affected his career, did he feel safe, talking shit about your boy or like, what's up? And the ECI thing, like, what was the significance of that frame specifically? And he'd never messaged me back. Just instant ghost.
That's pretty soft, though, man. I mean, you came at him. I mean, his own shit implicates it. I mean, yeah. I mean, I get it though, but just no response at all. That's man, that's a little chicken shit, don't you think? I mean, they act like science,
No.
yeah, like you just write a paper. Look, you go write a paper and get it peer reviewed and win your Nobel. Man, what the f, dude? These people can't even take a slight detour down that
Brian,
road,
dude.
or they're shunned.
You asked
Possibly
him
he
like,
thought he was going
you asked them like, "Oh, do you think that they not know and they just got caught up?" And it's like, no, dude, he full well understands the implications. So that's why when Alan was like, "Hey, I love your work," asked some questions, he was like, "Yeah, enthusiastic, energetic, sure." And then he's like, "Hey, so about that ECI frame, why do they have to transitive all coordinate?" Oh, I don't want to talk about that. Right? Like I instantly decided, nope, that's not the conversation I want to have because he's full well of the implications.
Sorry, man. I was just saying maybe he didn't want to put those words to paper. If he started discussing that, then it's all on official record in a way. It's coming from his email.
Exactly that. Like that's why he was like, "Nope, disengage."
Yeah.
Because like, what if this kid's a flat earther and puts it on his YouTube channel and then like lists my name somewhere? Like that's probably his exact fear.
These new age earthers in their screenshots, man. Can't even just send a message and delete it real quick. We'd be done screenshot up. Too late. We got it. You said it. You're owning up to it, motherfucker. No, I'm just joking, man. email,
Oh,
though,
dude,
you
Coach
are
Show's
kind of
back.
task. Anything you say through email is there written down. You're kind of pinned down. It's almost worse than a conversation, you know, as far as career wise, if anybody wants to hold shit against you. But dude, you developed a rapport and everything, you know. Yeah, it's just crazy how he just cut it off. One word, not even 3 letters, ECI, and bam, cuts off. It's ridiculous.
It's all
Well,
good, man. I hope he lives long and prosperous. I'm glad that he didn't tell me, because then it would have been, then I wouldn't have a cool story of figuring it out. It was much more gratifying going through it. And then if you
Yeah.
watch the Witsit stream part 2, or of the In the Field, you can see me figuring it out live, like 20 minutes after the conversation. I'm like, oh shit, is this like, then we have a full discussion about it live, and it was awesome. So
Instead of just leaning on Wang, right? Wang
yeah, instead of
said it.
just somebody gave me the answer, like, it's like, it was way more fun to go through it. So that's what's up. Shout out to Wang
Plus,
making it hard, dude. I respect it.
Also, to be insta corroborated by like doctorate, PhD, like Bennett, like researcher in the field, like, oh yeah,
Yeah, it felt good.
yeah, that
What
was
up,
an awesome
Matthew?
presentation.
How you been, man? I haven't spoke to you in a while. How you been?
I've been doing okay. Yeah. Happy
Oh, yeah.
Thanksgiving almost.
Nice. Oh, dude, are you
Pretty
about to
Thanksgiving.
square up with that turkey, dog? See, Shane, I can make it work with anything, bro. What's up? Test me.
Next week, yep.
Yeah, that's what's up, bro. Did you enjoy the Einstein presentation?
Yeah, I mean, I don't know much about that side of things, so I don't feel qualified to respond well to that.
I don't like that answer, Matthew. And like, it's like a pivotal, like, foundational understanding and the adaptation of science as you know it. For you it's a foundational belief for your rhetoric, and you're like, yeah, I'm not really interested in that.
No, it's not.
Yeah,
I mean,
because
I
you
can
wouldn't have that foundational belief if they heard all this stuff that Alan's throwing. It's got to have him questioning shit. At the very least, it's got to have him questioning stuff.
You need relativity, and you need Einstein. You need E equals MC squared. You need all that.
No, you don't. They didn't
What do
have
you-
it in the 1700s.
What do you mean you don't?
Moving, you do to keep the Earth moving. You absolutely do.
No, you don't. In the 1700s, did they have that?
They didn't have the Earth moving.
In the 1700s, they did.
I don't think they thought they were spinning back then.
Yeah, they did. You just study history. What are you talking about?
So here's a 1898 paper from your boy Wilhelm Wynne. And what he goes over here, it's a list of 10 experiments that show that it's either a no conclusive or a falsification of Earth's motion. And
So did Wilhelm think that the Earth went around the sun, or what did he think?
yeah, despite all the evidence that it's not, like like that's what's crazy about it, right? Actually, I don't know what Wilhelm believed. I assume he did, though.
Yeah.
Well, this is kind of like a scenario like Hubble talks about, right? Where everything points to the Earth being in the center, but we can't actually have it be that way. So we'll just figure out some philosophical, standpoint to ensure that the Earth isn't actually in the center of the universe.
Yeah, so you're right about that. I disagree with Hubble. That was a philosophical reason. He says we can't be in the center, and I think we could be. But I would say that the solar system is generally near the center, not that the Earth is the very center.
Sure.
That's what I was
So
going to say earlier, man. Ever since. Go ahead.
I was
What's
just
your
gonna
favorite
say,
center?
do you know how they has there been a measurement of Earth's orbital rotation around the sun ever?
No, they just do calculations.
Do you find that interesting, especially when we have the technology that is far beyond what we need as far as accuracy to be able to measure that motion?
Yeah. So what's the problem with measuring it the way they do? I don't understand.
Interferometers don't measure. That's the problem, right? Like the super sensitivity that they have and do, they go to measure it, right? And then they can't. They don't. They fail. It's never been measured.
Yeah, right. Matthew, the problem is you can just say, well, if we were doing this, then the calculations would be this. Like, that's fantastic to just hypothesize about that. But when you have the actual instrumentation that would be able to measure the movement, like physically, and the claims that everything else can be measured physically on its movement, why do we still in 2023, almost 2024, don't have measurements of Earth's orbital motion around the sun? Do you find that interesting?
Yeah, that is interesting. I don't know why.
I could think of
Alright,
one. I
that's
could
why
think
I
of
like
one reason.
Matthew.
I can think of one really good reason.
Oh, that it doesn't exist?
Yeah,
Correct.
the
I think
simplest
that's the wrong
explanation.
reason.
But it's the simplest. It's the easiest, right? It's the most logical. Hey, we don't have
To
any
main-
measurements because no one's ever measured it. Right? It's an easy
Yeah,
logical
and to
deduction.
maintain it, man, to maintain it, we'll throw out everything. We'll throw out every experiment. We'll start throwing out ether. We'll start shrinking apparatus. Dude, we'll start expanding fucking everything around us. Whatever it takes, boy. No matter what it shows us, we'll find a way around it.
Right, because they have other reasons for thinking it to be true. So that they come up with excuses to figure out why the measurement interferometer isn't working.
Oh,
Well,
yeah,
no,
that's-
they don't. They just have a belief system in something that's not even like, that doesn't even adhere to the mathematical framework that they believe in, right?
Right.
Well, they
I mean,
just
it's
kinda-
based on a preconceived notion that the Earth rotates around the sun.
They definitely come up with excuses. That's for sure. They do it really well, actually. They'll come up with all sorts of reasons to keep believing the things that they already believe.
Matthew, let me ask you a quick question. Is it even possible? Okay, they say that things are moving faster, like light and everything, because of gravity. The higher we get, is it possible that space is just not expanding as we get further away from the ground? Is it even possible that what's above me and below me is going to move at the same speed, period? It's not covering more ground. So maybe things aren't really moving faster further up. We're just covering the same amount of ground. Is that even possible?
Yeah, that's definitely possible. What do you mean
Fair enough.
covering the same ground? So all motion is relative, right? It's like how fast something is moving based on
No.
what you use as the 0 point.
Oh, only kinematically.
Yeah, that's
It's
what I mean,
that's
kinematically.
been So, and that's really what the crux of the Einstein's theory is. It's kinematics, and it's stitched together with a with an adherence to something called covariance, which gets violated in and of itself to maintain the ability to to continue calculating under the premise of satisfying conservation laws. So it's like so the big distinction here is like these people say that time physically changes, right? And it dilates, right? And that like length actually contracts physically. And so here's where it gets interesting, right? The high level relativists will tell you that the attraction is apparent relative to the observer, even though that doesn't make any sense, because then you would lose the ability to explain Michelson-Morley if it's not a physical contraction. So the high level relativists that forget about Michelson-Morley and like want to get all big brained and shit will straight contradict themselves and throw out the mandatory physicality of the contraction to explain Michelson-Morley. And so like you'll get contradictions right off the rip with that. Is it apparent? Is it physical? But they need these explanations to explain why there's no motion, because they have very precise interferometry experiments that show that they can detect motion like super accurately, and the only thing they ever detect is a fluctuation that corresponds to the motion of the stars.
Go figure.
And it's like
Yeah.
Wait,
and
they
within that,
do detect the motion of the stars?
it matches sidereal time, the fluctuations.
So
And the
so
equinox.
the Earth, the reference frame of the Earth and the reference frame of the stars do have a different reference frame, and that is measurable.
The stars move
don't
over
even-
the Earth, and we measure that. Yeah, it's easy.
Yeah.
The stars. Think about this. Like if something's moving on the ground, let's say 500 miles an hour, and then something is above it, 500 miles, and it's also going 500 miles an hour. Okay, you have to say that it's moving faster, even though it's directly above me, because on a globe it's covering more ground.
Yeah,
So you have to
2 miles an
say-
hour faster. That's not much.
So you have to say that it's moving faster, that things are moving
Well-
faster, and it's the gravity and all this. It is in
Dude, that's
reality,
why
we're moving at the same speed.
That's why it's all about reference frames, right? Because we're observing motion. That's what this whole thing is about. We're observing the sun, cause sunset and rise and set every day. You guys are ascribing that motion to Earth rotation and claiming to measure it in all sorts of crazy ways. And we're saying, well, actually, every measurement we've ever taken of that rotation coincides directly to not only sidereal time, but peaks and flows, max and mins on the equinox precisely known to like coincide with the solar minimum and maximum. So when you say that it's the Earth moving, and the measurements that you're claiming, you have to come up with those sorts of crazy interpretations and extrapolations to make it make sense. And we're saying you're measuring the sky, and hey, look, it coincides with the sky, and hey, look, it matches the sky, and hey, look, it coincides with these measurements. Wouldn't you think that our case is stronger?
No, I think it's just all relative. So it doesn't bother me.
See, the danger of E equals MC squared, guys, right there. But
Yeah.
more relativism has seeped into this, so nothing's matter, everything's relative. Jesus.
Yep. And here's
I'm just slowing down.
here's the stationary lab frame making the only correct prediction on how to interpret the speed of light. So there is no dynamic relative motion. It's just a kinematic fantasy that people have been tricked into believing has physical meaning through lies about experimentation regarding the motion of stars during an eclipse and in the Pound Repka experiments and shit. Like that's like literally the best best so-called experimentation for an interaction with that they say that light has an interaction with a so-called gravitational field and or the curvature of space-time. Those are the best experiments they got to like tie it all together and make it real. And when you look into it, that's not even the case at all. Like the guys that did the experiment don't even agree with what they got. Like they weren't able to make a determination between relativistic effects and classical mechanic effects. So
Dude, the amount of hoops you have to jump through to like scientifically justify the nonsense that you have to believe to interpret it that way is insane.
It's like Matthew. It's like you can say that all motion is relative or whatever, but then it's like you can look into the experimental falsification of that and how the lab frame is the only valid frame, and the implication of that is that it's stationary, non-moving, and the only way to interpret the results that we're getting is that the Earth is stationary with respect to an ether wind that's basically corresponding to the sidereal rotation, right? Like that's that translation of motion. Because as you go higher, right, the readings get stronger.
Oh man!
Yeah, they would say if you got an underground wire.
Hey, Brian, relax. Let your boy talk. Dog. I know, but we need to get the other guy with me. All right, sorry about that.
Yeah, I would say I'm sort of uncomfortable with this idea of like contraction or time dilation or lots of the basic assumptions of relativity. So I'm suspicious of the whole thing, I guess. And I don't understand all these results you posted. I don't know.
No, you're good. You're good, bro.
But so that's the other thing. Like you and Ruhav demonstrate. Like you're like, yeah, I'm comfortable with all the heliocentric positions and belief in philosophy. And like that cornerstone of relativity, I don't need that. I don't care about that. I don't care about that. I don't need to know about it. You telling me it's wrong doesn't have any effect on me. That's a weird position because
that's the way that everybody thought in the
I know
16, 17, 1800s. So I'm with 400 years worth of scientists saying that.
Well, so Einstein, like the relativity bailed that whole out, right? That's the whole point. That's the danger of equals. That's what we were talking about tonight. That's the whole tie-in.
Yeah, so if Einstein was wrong, we just go back to 400 years ago and, all the same things, all the same proofs for the globe still hold.
What 400-year-old proofs of the globe are there?
Just the relative motion of the planets and the stars and explanations of eclipses and moon phases.
Things in the sky move, and we make predictions based on the motions of the sky things.
If Einstein's theory are falsified, though, then there's no relative motion, and the only way to interpret all of the events you just listed is from a geocentric stationary position. Yeah,
Well, no, it is.
The only way, 100%.
No, that's not true. It's all
Yeah.
relative about. So
No.
I'm talking about relativity in respect to measuring motion, not like Einsteinian relativity.
No, so the the distinction though is that they've told people that their equations have physical meaning, dog.
Yeah,
They're saying
they
time
probably
bends
think
and
that.
stops.
Yeah, that seems weird to me. I don't know if I believe that.
That's good. That's like because you're a rational human, right? That smells fishy, so to speak. That's because it's complete and utter bullshit, man. It's fine. It should smell funny to you.
But all of this is just about the motion of the Earth. It doesn't say anything about the shape, right?
It's about the motion, right? And you're incorrectly attributing that motion to the Earth against all signs, measures, experiments, logical deductions, visible evidence that we have. You guys have attributed that motion to the Earth, and we've attributed it to the sky properly, as it coincides again with not only sidereal time but effects in the sky and then peaks right at the equinox and the solstice. So if that isn't evidence that what you're actually measuring is the motion of the sky, I don't know what it is, dude.
Yeah. So the point is that all of this is about motion, not about shape, right?
I agree. That everything that I put forward tonight wasn't about the shape of the Earth; it was about motion.
Right. Okay.
Wait, was that it, Matthew? Was that your
Crumbles,
whole
though, man.
statement?
Yeah, I mean, but that you even if you're right, the worst I'd
Yeah.
have to do is go back to the geocentric model.
Right. Well, that's cool.
Good start.
Well,
Yeah,
step
we'll
one, bro.
start there.
Step one, dog. Yeah, like I said, like we'll take it, bro. Like
Well,
you know
come
what I'm
on
saying?
board, Matthew. Come on home. Let's go.
Like
Let's
that's
go be
phase one,
globular
dog.
geocentrists together. We'll
That's
give you the
phase-
shape of the globe, and we can be geocentrists for a while.
Well, yeah. So to be fair, I'm not actually going to become a geocentrist. I just
I
trust
know.
what the people say. I can't defend all of these
Right.
things you're saying. I can't defend relativity.
Well,
but
you
I
know,
still believe it.
You know, Matthew, it's not only you that can't defend it. It turns out nobody can defend it because it's retarded and wrong. But I'm just trying to attack the belief that actually, like, you don't need relativity. It's not important, even if it is wrong. Like, I can still have black holes and theoretical physics and bending of warping of space time and all the derivations of the modern society that come from that. You think that all that just comes with it, but the basis behind it doesn't matter, and it would never. Like, I don't understand that, man.
All I'm saying is that everything that was presented today would have not deterred Newton, because he didn't think that Einstein
Newton believed in ether.
Yeah, Newton believed in
it wasn't part of
gravitation as a.
his.
He
what's up,
believed in
Bacon?
it
It
as
wasn't
a
part of
pressure.
his
He
theories,
believed in
though.
it. Yeah,
That's
he believed
true.
in it
Yeah,
as a
he-
pressure mediation.
That's right. He didn't like action at a distance, so he thought there was some kind of ether. That's true.
I mean,
Real
even
quick,
Einstein says that he can't imagine space without an ether. Like, you just can't work out the dynamics without having an ether. Like, seriously, even Einstein understood that.
wait, you
Right.
can't just stop at geocentrism, though, y'all, because just
Yeah, you can.
real quick, if you throw,
Yeah, let him
Einstein-
stop, dude.
let
It's
him
fine.
stop.
If we could get Matthew to be a geocentrist, like I'll take it.
For
You know
real.
what I'm saying? Like that'd be hilarious.
Yeah, but he's got to.
But like in a good way, you know.
You got to.
Good step.
I'm with you, but you still there's logical conclusions. Like if you got a wire underground going 1,000 miles country, and then a wire above ground, and you have to because they got from beginning to end at the same time. You have to say that time slowed down for the one underground. Like, dude, relativity explains the fact that shit's moving at the same rate, so it doesn't just stop. I mean, that's just one little quick example. It crumbles like a house of cards. The globe does. Yeah, we should just get him on geocentrism first. I see what you're saying.
Well, dude, it's cool that he's questioning. Like, hey, this thing sounds wacky. This time dilation seems a little bit not like, because that's true. That's all valid. Let's use that. Let's go with your natural instincts and your intuition, Matthew.
Fair enough. Yeah, so I'm not going to become a geocentrist. I have a high level of trust in people who understand this better than I do. So I think that, I know you say that I don't have good answers for that, and I don't, but I think that some people do.
But they don't. Nobody does.
Well,
Otherwise, we would have
you know
presented
what's
them.
cool though is like if you try to like learn some of it and interpret it yourself, and then ask them so that you're not so reliant on their interpretations. because I made the mistake of like heavily relying on someone that has, you know, academic credentials, and I would just like I would like front load some relativity stuff to him and just be like, yo, does this debunk your religion? And he'd be like, no, of course not. And I'm like, oh dang, you know. And it's like I really had to like look into it for myself, you know what I mean, and like figure it out. And then it was like, it's not everything the way that they interpret it is wrong and experimentally shown to like invalidate their position. And when you confront them about it, they're just like, you think you can question Einstein? You think blah blah blah, and it gets like very religious, right? Like it's like, you know, if you take like when it devolves into that, it's no longer argumentation about like the logistics of the situation. It's about your adherence to the correctness of Einstein, irrespective of, you know, reality. And that's like seeing that. It's like you can ask them all kinds of stuff about this, and the chance, like, you know, you're rolling the dice on whether or not they're going to be like, oh yeah, that Wang experiment actually is super damning, like I need to look more into this. They're just going to be like, nah, all he did was a mathematical trick, it's all good. It's like, what? You know, so
A mathematical coordinate system transform.
yeah,
Pull the wool over
just
your eyes.
something, yeah, just something to consider, bro. Because I used to, you know, believe in that stuff too, man, and give
Yeah.
all my adherence to it.
Yeah, and so that's why when people ask me why I think that the Earth is not flat, I don't bring up these kinds of things that I don't understand as evidence against the flat Earth, because I don't understand it well enough.
Like, but you don't believe us when we say it's actually not evidence for you at all. That's why we keep talking about it and giving each other presentations on it, right?
No, I'm talking. Yeah, that's why I'm saying that this stuff about motion and ether and relativity is not something that I usually bring up in this argument, because I don't understand.
Do you think it's important?
Oh, probably so.
Okay, but like, so I mean, I guess it would be safer, like if I was you and if I was a believer heliocentrist trying to maintain my law, I would probably not look into it, even though I suspected it didn't sit right with me. It sounded a little goofy. Like I probably would just assume that smarter people than me figured it out and everything was fine, rather than have to challenge my own belief system. I think that's probably what I would do.
Yeah, but to me, it seems like these things are on the fringe edges of the theory. Like the basic idea that the Earth is a globe and that the sun and moon are where they appear to be are kind of more basic things that normal people can look into. Like, I'm not going to do interferometry, light speed, relativity experiments, so I stick to the easier stuff, I guess.
The easier stuff.
Yeah, like sunsets.
Yeah.
Yes.
Well, I guess it's more in regards to the nature of the realm and reality itself, right? It's like, what if they told us about the existence and our place in it? Because it's a total facade that's backed up by abstract mathematics used to keep you in a system of belief about the nature of the things in the sky, right? And to control your interpretation of what they are. Like, you know how freeing it is to like not know what they are, and to be like, to look up there,
filled with discovery,
to just look up there, and be like, what the hell are you? And it's not. Oh, it's a ball of gas, nuclear reaction, fusion, and or fission, depending on your belief system. And it's like, oh, okay, dude.
But like,
that's not.
dude,
yeah,
dude. I
when
like
you realize
Matthew
that when you yeah,
It is
Go ahead.
liberating.
because he's always like, yeah, that makes sense. You're like, hey,
It's
isn't it weird that
liberating.
we've? Sorry, dude.
Oh, I was just going to say it's liberating to not know anything about what makes the sun go.
Yeah, Twinkle Twinkle Little Star. How I wonder what you are. The song for the beginning of time, bro. And Twinkle Twinkle Little
Dude,
Star.
like, if you ask
When you-
Matthew,
yeah. When you look into the interpretation of how they say it works, it's like, oh well, that's not it at all. Like they fired that guy Eric Dollar got his whole career ruined over talking about how the sun isn't a nuclear fusion reaction and all that shit. And he was like talking about how it was like electric energy from another dimension, basically. And he has all these experiments and what's it called? Like what do you call it? Like working technology or whatever that works off of the ether and stuff. So it's like, is that guy crazy, or is it, or did he figure out that like what they said about it isn't real?
What do you think?
but like, But like we were talking about motion, like, oh, isn't it weird that we've never detected Earth's orbital velocity? And Matthew's like, yeah, that is a little weird. Like, well, his first reaction was, well, we've calculated it. And
Yeah,
Napalm pressed
calculations
him.
are good enough for me.
And Napalm pressed him a little bit. He's like, yeah, sure, you can, but have we ever measured it? No. Well, isn't it weird? Well, no. Well, how come it's not weird when we have the instruments with the severity and the degree of sensitivity well beyond the threshold required to measure such a tremendous motion, yet no motion has ever been detected? And he's like, oh, yeah, I guess that is weird. And onward we moved. But then we went right to relativity, which was decimated. And now he's like, well, I don't really like to defend it with that because I don't understand it. But yeah, it probably is important. Yet I don't want to defend it, and it sounds goofy. Is that about where we're at, Matthew?
Yeah, that's pretty accurate. Yeah.
All right, nice.
Oh yeah, brother.
I feel
That's
like we
what's
made
up.
progress.
Yeah, hell yeah.
I mean, I usually stick to debunking the flat Earth and not talking about proofs, not talking about these things about the globe. Proofs for the globe, I think, are hard to come by.
Proofs for the globe hard to come by. Yeah, extremely hard.
Yeah, I would call it evidence, and especially like the alternative being flat. There's evidence that can't be right.
Go on.
Oh, let's see, full moon. It appears the same size from all places on Earth, or within 1% from everywhere on Earth. Yeah, it's at different angles. So if it's a physical object, it's hard to explain if the Earth is flat.
Oh, well, let's just make it not a physical object.
Yeah, I mean, we can deny what we see with our eyes and call it just some other thing if you like it, and that's probably the best option you got.
Well, I think we got pretty good observable evidence for it acting more like a rainbow on a source projection, just like the sun, as opposed to any other solid object, and probably more evidence to the contrary, with things being like photographed through the moon and its weird different coloration going with the background that it's in, depending on which layer of ionizing gas it happens to be in, right? You got the things like the supermoon and thing. So I don't know. I think it goes both ways.
No, you just look at the
Well,
moon. Just
how-
get a telescope or a pair of binoculars, and you can see that it's a physical object.
Got a question. How do you think the prediction from the globe fits so nicely when you account for the parallax of the moon, for example? Like if you're trying to determine the path of totality of a solar eclipse, the globe is pretty much spot on. That would be really weird if the Earth wasn't a globe.
Dude, he said parallax. Get him, Alan.
Dude, he said a couple of things. He said parallax and lunar shadows, and I tapped out because it's not really related. So, do you want
But they are.
geocentric predictions?
But actually, this doesn't distinguish between geocentric or heliocentric. It distinguishes between a flat Earth and a globe Earth. Because you're definitely using a globe if you want to get the totality path right. And that does require you to take into account the parallax of the moon. Because the moon's a lot closer than the sun is. If you don't take into account the parallax of the moon, you get the wrong answer.
Go through the parallax of the moon situation. Is that the correction where the half rotation of the Earth, so-called, and all that stuff? Is that what you're talking about?
It's not related to rotation of the Earth, no. It's related to how high the moon appears in the sky given your distance to its ground position.
Yeah, I'm not familiar with the corrections that you're talking about for the predictions. I'm familiar with the Fred Espernak story and how they talk about it's something to do with it's similar to what you're saying, but they say that the only way that the prediction matches is because the Earth's a globe and they have to basically subtract 3 days from the prediction and then rotate the globe a quarter and a half times or something like that. And it's like that's the way that they talk about it. So unless you're talking about that, I'm not familiar with any sort of moon parallax.
Yeah, I'm not predicting where the celestial bodies are going to be in the sense
No, the
that,
shadow.
Yeah, right.
Yeah.
But the
Right.
shadow is going to be determined based on the relative position from the ground. So
Yeah.
you're in the shadow of the eclipse if the moon is in front of the sun, right? If it's not, then you're not exactly in the shadow of the eclipse. It's not going to be as dark, and you're not going to be in the totality path, right?
So you're saying those predictions can't be made on a flat Earth, though, or is like?
Maybe. I challenge that. I would love to see that, but I know they can't be done on a globe, and on a globe they're spot on.
Well, at this point, it would be a post-diction on both sides because all the data derived is already available through the Ceracycle stuff. So I don't know
False, because I did the
how-
prediction
Spot
myself
on,
without
dude.
using that data.
go on.
You got them changing the distance to the sun to 3 million or 102 million miles.
Yo,
because
Brian,
of
relax,
the
bro.
eclipse, you know.
Me and
It's
Duder were
acting
just
like they're
talking,
spot on.
and
They're on problems, bro.
Say that again.
No,
What
there
were
are
we?
problems, bro. You acting like it's all spot on. There are definitely problems that are given different explanations. Not even bringing up the selenium.
We're not talking about giving explanation. We're talking about predicting where the shell is going to be based on the ground position of those two bodies. I know if you use the globe to do that, it's spot on because I did that. I highly doubt you can
Check
do it
the
any other
timing
way.
of it. Check the timing and how
Well,
long it
no, it's
lasts.
reverse. It's post dicted, right? Of course it's going to work out on the globe because everything's transformed, so they can make sure that it matches their post dictions. There's nothing predictable
Like
about
what?
the globe, bro.
Like what? Well, what information am
Well,
I?
if they know what they need, right? They have the exact observations and they fit it to a globe. That's not proof of a globe. It's just
Okay,
reunification.
what information you think? What information you think I used to get the prediction that was reverse engineered by whoever you're talking about?
How did they do it then? You explain.
No, I know how I did it.
Okay, explain how you do it.
I'm talking about my prediction. All I did was I took the ground position of the moon and sun, and then I positioned them as if Earth was a sphere, and they were at the distances of the heliocentric model. And I got what position on the globe would align those two bodies and get the shadow. You get a totality path and when. And that prediction was spot on with time and date and stellarium.
But so Bacon, if you had the position already, couldn't you backwards
us your
engineer
data.
the distance to make that work?
What do you
Post your
mean?
data.
Which distance?
scale
Which is
invariance.
like, I mean, like exactly. There's a scale invariant relationship between the variables of distance. Of like, so when you know where it's going to happen, then you can backwards derive where the object should be to have it seen at that location, right?
What data exactly do you think it's being backward engineered? I mean,
Well,
I use very little amount of information.
I'm
Very little amount.
arguing the distance can be backward engineered. So what
I wasn't using any distance.
what data did
Oh, I mean,
you
you mean the
You
distance
said
to the
that-
celestial bodies?
yeah.
You said the distance based on the parallax.
Right. No, yeah, no,
So-
that I use, yeah, right.
Right.
Well,
Yeah, I got from the almanac. The nautical almanac has that data there.
yeah, and the almanac gets data from guess where?
Observation.
Dude, you guys want
The
to
same
see
place
a quick
NASA got it from.
No, I mean you can challenge any of the data in
Which
the
is-
almanac, get a
which is the
section,
old-
prove it wrong if it's wrong.
It's the old Metonic cycle, though.
It's just observational data. What do
Yeah,
you mean
it's-
prove it wrong?
Like it's you've used the same observational data.
So if it's
projected.
observational data, then I'm not backwards engineering anything. I'm just using data we can all agree is correct. So how is that I'm using data? Hang on a second. Let me just finish my. Let me just finish my sentence, please.
Hold on.
Can
Point
I?
to me.
Well, I was in the middle. I was mid sentence.
Why
Can I
Let him
finish
talk.
that
Let him
first?
finish. Let him finish real quick. Go ahead, Bacon.
Thank you. Right. So I'm using data that we all agree is observable. It's not backward engineered information. It's just data we can all observe and
Okay.
confirm. And what I'm predicting is not part of that data. What I'm predicting is something else that is derived from the data that is observable.
Cool.
Okay.
So within the data set, where does it explain distances to these objects?
It doesn't.
Okay, thank you. That's all I needed to know.
Yeah, that's something depends on how you are interpreting the data. If you interpret it as a flat Earth, you're going to get one answer. If you want to interpret it as a globe, you get the right one.
Yeah, you're not biased at all.
Yeah, I mean,
Hey,
show
Alan,
show
what
how
were
you
say?
how you're going
You
to.
were going to show us something.
Yeah, the almanac. I'm looking for where I have it saved. So it's like, where was it? In 1776, there was a royal decree by whoever the king was at the time, and basically what he said was, hey, we're rolling out a new longitude coordinate system, and any map that comes out that doesn't adhere to this is now illegal. And then under that, he has a bounty for, or like a rewards program for people to go out and do observations where they do celestial navigation around Britain, and they come up with the coordinates, or they come up with a way to match the coordinate system so that two observations can navigate around Britain. So basically, they were coming up with the 39, 59, radius and all that sort of stuff for the globular coordinate system, and matching it to what they were already derived for, like the quote unquote sphere, right? To make everything fit. So when you get into the distances assumed, there's a scale invariance there that's going to be proportional to where they had to move everything to say that, oh, it's because we're on a globe that you could see it at this angle because it's at this distance, blah, 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 even though it's all based on angular size when it was derived, right?
Completely.
So from your source.
I'm not sure how
Sorry,
that.
sorry.
Sorry, I thought you were done.
Yeah, I'm sorry, go ahead.
All right. Yeah, I think like what brought here wasn't addressed because still the data I can post the data used. I know how to interpret that data as if we're on a heliocentric model, and I can tell what the shadows are going to be based on that very minimum amount of data that we can all like it's just observable data. And then your guys are all free to reinterpret that data as a flat Earth. Like, okay, let's say Earth is flat, and we have that same observational data. How we're going to interpret that to get where the shadow is going to be, where the totality path is going to be, and when it's going to be. You're free to do that. If you get the right answer, then kudos to you. But I don't think that has been done. Go ahead, Brian.
You're acting like it's perfect, okay? I just posted 3 videos of how your shit is most certainly not perfect, and I didn't even throw in the selenium yet. So just check out, just browse through them if you want to see the problems. The sun and moon angles are perfect by no means, bro. You can act like they are, but they are most certainly not, bro. There are problems with the time of the eclipses, some of them, with the angles, and dude, they've had to move the sun further out. I know you've heard of that. Whether you want to look into it or not, I know you've heard it several times where they literally had to move the sun further away just because of the 2017 eclipse, and they're getting different results with different eclipses and shit. So something's wrong. Maybe some of these distances are off a little bit. Maybe the angles are off a little bit. But you act like your model's perfect, bro. It's not perfect, bro. I don't even know why you say that.
I didn't say it's perfect. I said that my prediction match was spot on to time and date and to stellarium, which is the kind of software that like photographers use when I get a photo of the solar eclipse. Like they have to know exactly when it's going to happen, when they have to aim, if they want to get it right. And they use these kind of softwares, and they're able to do it. So I think those softwares are spot on, and my prediction were spot on to these softwares. But it doesn't have to be perfect, but within practicality, it's pretty much spot on. I'm not saying there's not any observation that doesn't match it. There might very well be, but the one I'm bringing here, I don't see any way Flat Earth can get the same prediction, and I'm open to anyone that proposes a Flat Earth prediction for that.
Also,
but I really doubt it.
The Saros cycles don't predict whether it's going to be an annular eclipse or a total eclipse. There's another
You're talking about there's other things that predict that inside of it all comes from the Saros cycle, okay? And then you could adapt it to your model, but you're talking about a degree change between where I'm at in Florida and all the way to Cleveland and at the Great Lakes in Ohio. And you're talking about not even a third of a degree in some of these things. I mean, I'd like to see, did you literally take the angles, or did you at the available data? Because when it starts getting within half a degree, man, I think that's worth looking into. You know what I'm saying? That's all I'm saying. When it starts getting close, because the differences are not very big between the two models.
Yeah, I'm not entirely sure what you're asking, but I'll post the data that I used. You might be surprised that it was very little amount of information. You actually can remove, let me see, 4 of those lines, and it's still gonna work very, very well. It's gonna be slightly worse, but it's still gonna be pretty much spot on, even if you remove 4 of those lines. maybe 6. But anyway, that's
No.
data. I mean, you have the data directly from the almanac, which is, as I think we both agreed, it's observable data. And you have 2 variables, only 2 variables, Earth radius and sun distance, which it's just the standard of the heliocentric, the averages of the heliocentric model. I didn't have to reverse engineer anything. Unless you think you can tweak 2 variables and get every single solar eclipse right by just tweaking 2 variables. Don't think that makes a lot of sense.
I showed in one of my videos where I dated all the way back to 1980, and showed these declinations and freaking in the not even changing. Like they change once or twice and then change back. Like and it's like you got 50 years have passed, and there's no change in the freaking in the motion of these bodies, like the stars and all that stuff. Man, it's like we're supposed to be moving, and I know that the stars in your model are way, way far away, but if no motion over 50 years, then it's supposed to be like a third of a degree or something every 25 years or some shit. But I showed in my video, and I didn't just claim it. I showed the almanac, the nautical almanac, and showed the declination year after year after year. I'd skip 5 years and show where they ain't changing shit. Like people are claiming all these changes, they just ain't happening. According to the almanac.
You're saying
anyway.
the star data in the almanac is not changing?
Yeah, let me post a video. You just have to watch the very beginning of it when you get a minute.
I don't have to. I already looked into the almanacs. They change within the same year. What are you talking about?
No, I'm talking about within respect of each other.
Ah, all right, okay. Yeah. Proper motion is much slower than the most of the angular change in stars is attributed to the how do you call it? The precessional equinox.
I'll show you where the declination didn't change with any of these stars over 50 years, dude. The declination didn't change even a tenth. Let me
Yeah, I
post
wouldn't
it.
expect a tenth of a degree with 50 years, because now we're talking about proper motion, not
No, the declination. No. I'm talking about around the circle. But I mean the declination, that's different.
The declination does change. Of course, it might not reach a tenth of a degree in 50 years, but it reaches a measurable amount, because the almanac only measures to tenth of an arc minute.
I don't think you're hearing me. I'm telling you, it didn't change at all. Let me show it, man. Let me just quit saying it and just show it.
Sure. Yeah, there might be 1 or 2 stars that didn't change, I guess, but I mean, most of them, from January to December, they change within the same year.
Also showed in my Celestial Nav videos how the time zones are so fucking wonky. I just went along one latitude and went where it was -1, -1, -1, should jump to 0, right? And then +1, +1, +1, and then +2, +2, +3. Okay, it went from -1 to +1, back down to 0, then to +1 to 2. I'm like, dude, if I'm gonna make a model like this where I could just throw time zones wherever the hell I want, then dude, I could make any model work if I'm just.
Hey, you're frustrating me, bro. Because I brought an argument.
Watching videos, bro.
Okay, I brought an argument. It didn't get addressed, and now we're talking about something else. That's a bit frustrating. Where's Shane?
Well, I'm just going off the
Shane's not
fact
here.
that you're acting like the model works so good, and I'm telling you, I found so many problems, dude. I don't even know where to start.
Yeah, time zones are set by political boundaries. They're not part of the structure of the universe, so to speak.
Yeah, but if you're going to refer to the UTC to get your position, your GP, then you've got issues.
Why?
Why?
UTC is universal.
Exactly.
If I'm at -2 UTC, and I'm really at -1, the fact that it's universal means shit should be consistent throughout, and I'm subtracting the wrong amount of time from the universal
UTC.
Yeah, but
No,
when you
UTC
say
is the
I'm in,
same.
A video, man, about cell nav bacon.
No matter
Yeah,
where you are
when
on
you
Earth,
say
UTC is the same time.
yeah, if you say I'm in -1 or -2, if you're talking about you're in as you're within the boundary, then now you're talking about the political decision of where they're gonna use those time zones. You're not talking about UTC anymore. You're talking about the arbitrary boundaries of where each time zone is gonna be used. But if two people have, let's say, if you say let's call each other at 3 o'clock in the morning, I don't know, November 20th of 2023, everyone is gonna do it exactly the same time.
3 o'clock UTC.
Yeah, 3 o'clock UTC. Yeah, no one's gonna disagree. No one's gonna get it late to that call. Everyone's gonna be on the same time. Doesn't matter where they are because you're specifying the time zone. And UTC is just the universal one, the standard one. If you're talking about where you are based on where those time zones are being used, now you're talking about political boundaries, as Matthew just said. We're not talking about something that is universal. We're talking about something that is arbitrary, which tells you nothing about the shape of the Earth.
Did you know that Whitsitt used to say that there was a problem? There's too many time zones in the southern hemisphere versus the northern.
Yes, and I was very impressed that Whitsitt used that argument because I thought he only used the better ones.
Right. No, I thought that was interesting. I haven't heard him say it lately, so he must have figured out that it was wrong.
So Matthew learns the picture that you posted of the sun rays, the corpuscular rays, and then you're claiming that they're all parallel, and using the example of the train tracks. If we were to get
I'm
those,
saying it's consistent. It's not evidence one way or another. It's just saying that there's nothing inconsistent with them being parallel. I'll put it that way.
Well, if we were to get those train tracks, and let's say we were to put them 90 degrees to each other, they would still end up pointing at the same place. But would the two sets of train tracks 90 degrees to each other be parallel?
He actually just addressed it.
Yeah.
Yeah.
I mean,
and he did. And you remember when every Glober I've ever met said you could stand on a beach and watch a boat go over a curve of water?
Yes.
If you want to dig on somebody. Yeah, maybe wait till Whitsitt to defend himself. Yeah, you still say that. You see a boat going over a curve of water? Or that's how we see in the distance.
Well, you have to use binoculars or a telescope, but generally that's what happens.
Yeah, every Glober says that's the curve of Earth of what that's what you're seeing.
Yeah, that's what.
Right.
Happens.
That it can't happen in any other way. That it's the physical curve of water. Right. That's what you stand by, right?
Right. Pretty.
So they're still saying it.
Yep. Still true.
Wow. That's nice.
So then you're saying that the horizon is where the Earth curves?
No, it's an apparent place. He has to say that, right? But he's just going to turn around and doublespeak and say it's a physical place where the boat's being obstructed bottom up by the physical water. And act smart. And then talk about somebody that's not here. Which is also dumb. Pointless.
Wait, who was that? Who was I talking about who's not here?
Whitsitt's not here.
Oh, yeah,
you
sorry
made
about
a pointless dig at him. That's why I made a dig at Glover.
No, you're right about that. I did. He
right.
is kind of a,
Thank
no,
you.
I won't say anything more about him.
Thank you. So you still say that the blockage of the bottom of the boat is still a physical place of the water curving?
Perspective makes things get smaller.
I didn't say perspective. I didn't say perspective. I said, do you think that the obstruction of the bottom of the boat is a physical place of the water curving? Never mentioned perspective. Nice try, though.
Yeah, I wouldn't call it a place. I would just call it blocking the bottom of the boat. So perspective.
I mean, the horizon isn't a place where the ground meets the water? I mean, the sky meets the water?
Well, that's a description of an apparent place. So, yes, it apparently looks like the sun or the sky meets the water. That's the apparent.
So not physical. Not a physical curve of water that's obstructing the bottom of a boat.
It's just physical and apparent.
It's physical and apparent.
Right.
Never heard that one.
That's how everything we look at is. You look at a house, you look at a car, it's physical and apparent.
So the horizon is a physical and apparent obstruction.
No, it's a physical obstruction blocking the bottom of the sun halfway through a sunset, and it's also an
That's
apparent.
not even true.
No,
I'm sorry to cut you off, but that's not even true in your model.
have you ever seen the sun set over water?
I've seen plenty of sunsets. What does that have to do with your model? What you're saying doesn't match your model. Your model says that it's already set more than half.
Right. And so the location and time are off by a little bit, but I'm saying you can't see the bottom of the sun, but you can
A
see
little bit. Yeah, who says you wouldn't be able to see the bottom of the sun? That's the whole point.
It's closer to you.
What?
The bottom of the sun is closer to you on a flat Earth than the top of the sun.
Yeah, but at certain distances, it doesn't matter if it's a fraction of an inch closer to you. It's still going to be obstructed by the other things that aren't physical, like how we see over distance or through thicker layers of atmosphere. I think someone said that earlier. Should have screenshot it.
Interesting.
Interesting. That was a Glover saying
No,
that.
I'm saying interesting. Your incredulity. That's okay.
No, the interesting part is how you appear to make yourself as the smart one and then contradict everything that you say. I'm glad we got past the Witsit thing. I'll let y'all continue.
You know, Witsit never talked about. He said that he knows the time zones are man-made and blah blah blah, but he just said that on a flat Earth model, the South would be bigger, right? And that the 30 whatever in the South and the 19 in the North, kind of does indicate that. He didn't make it as if obviously they'll just say that it's man-made. I don't think he was whatever misconstrued. That's all I'm pointing out.
So you're saying basically the horizon is where the Earth goes? Or what's your deal with that? I just want to clarify that.
Well, I'm just saying that I think that saying that he was claiming that is kind of misconstruing what he was saying. Like it was
sorry,
than just there's more in the South than in the North. Like that wasn't what he was pointing to.
I'm asking Bacon and that. I just want to get clarification from Bacon or Matthew that the horizon is where the Earth goes.
Horizon is where the ground appears to meet the sky, and that is caused by Earth curve. So it's a physical obstruction, but we see it in an apparent manner. And so when the sun is setting like at 21 past